It's Friday night live on the Moon stream. Thank you for listening to WPK. I guess it would be PKM. PK Moon Watchers. Welcome to the Friday night, ladies and gentlemen. Live on your screen, you're seeing the lunar surface and all its gray glory until we go to a wide field. Then we'll put the color back. People often ask us, why do we just show it in black and white? Well, there's two answers for that. Number one, there's a little thing called chromatic aberration. And if you leave the color tones up, you're going to get little rings on the craters of blue and green and whatnot. The moon is not black and white or gray and white. It does have color. There's some browns, there's some blues, there's some, there's tinges. It's not like super bright, but it does have color, which I try to bring out in the wide fields because that's the best way to see it. So don't ask me what I'm doing on the microphone either. I'm just something to do. It's Friday night. Who do we all got in the chat? Let's see. Of course we got Rockstar. He's been here for a while. Moderator. Let's see. Can anybody hear me, or am I the only one? Am I talking to myself here? I don't know if you can hear the music coming from the speaker. I'm trying to keep it low so it's not like an echoing thing. But yeah, as the moon rises, it's going to get clearer. It's going to settle down a little bit. It's going to go up towards zenith. And for anybody that doesn't know, your best time for viewing is when the moon is at its highest point in the sky. Whether that be straight above you, or whether it be, south of you or north of you, depending on which hemisphere you're in. When it's at its highest point, that's going to be because it's that's the least amount of atmosphere you're actually looking through. So it would be the calmest. It's not bad. I mean, that's not bad tonight. Here on the East Coast, we're getting walloped. And I do mean walloped. Like 70-mile-an-hour winds all the way from Baltimore up to Boston. It's just crazy. And I'm actually surprised, like, I'm one of the few areas that still has the power on around here. And of course, Paul texts me up and says, "It's beautiful down here," which it usually is. If it's crap up here on the East Coast, Philadelphia, Baltimore, New York, Boston, it's usually beautiful in Miami. And that's the pattern we've seen today. I am going to see if Robert S's is fake. Yeah, it's fake. Yep. We pay thousands of dollars for somebody to do, they give us 3 hours of CGI. The moon. Come on. I'm actually going to jump off here real quick. I want to see if I can get some people in here. I'll be right back. Let me see who's all around. Back with you shortly. Hang tight, Moonies. Yippee-ki-yay! Alright, we're starting to gather people.
Well, I saw 50 in there, yeah.
I'm talking to you. We finally gathered you. I put the message out on Skype.
Oh.
And we are live, back live. I found Mark.
I'm here.
He was downwind protecting his observatory.
I sure was. We had winds of like 60, 65 or more miles an hour.
Topped out at 72 here.
Wow, I believe it.
It's going down, but it's still probably going about 50, 60 miles an hour. And trees down everywhere.
Yeah, I believe it.
It's nuts. It's a hell of a nor'easter, man.
Yeah, it is. Yeah, it's it's crazy.
Yeah, and you know what? I was expecting, like, I went out about, I don't know, I guess it was about noontime, and just snow. I mean, it looked like an actual blizzard. Now, it wasn't laying on the road or anything. It was kind of laying on the grass, but it looked like, I mean, something straight out of hell, man. It was like crazy looking.
Well, you don't get snow from hell. I mean, you know.
We do in these parts, Mark.
Yeah, right.
Ted in the chat there said he got his crater today.
Awesome.
And is happy with it. And he said he learned something within the first 10 seconds, but I was connecting articles, so I didn't actually read what that was. So, Ted, if you want to tell us in the chat.
Yeah. What did you? I'm glad you got it, Ted. Thanks for letting me know. Do you like it? That's the question. Do you like your Tsiolkovsky crater?
Did you ask Amanda if she wanted on?
Yeah, she'll come on. She
Okay.
says she's fine.
Let's see here. So we have this. Man, it's been a while since I did this. How do I do it? Okay, Mark. Okay, there's you. Wait, how do I do this then?
Lafayette,
I think it's just add somebody to the call, right?
Yeah, exactly. You can add as many people as you dare until you lose
okay, there
your...
we go. It was I had the screen down a little too far. Okay, add people. Let's find out if Miss Donnie wants to come hang out with the boys.
Y'all funny.
Mark, I'll tell you what, I received the most insane comment. I'll have to bring it up to read it to you.
From where?
From a stream about a month ago. Somebody left this comment on it, and I was just so blown away. Like my big thing is, when are people going to start understanding how exposure works? It's one of the simplest,
like camera exposure.
Yes. Like,
well, I mean, it's not that simple for people. I mean, some people, they just don't understand how, longer exposures mean one thing and short exposures mean another. Well, they don't understand ISO and stuff like that.
It's because this person came in and totally you can tell the smugness was coming off.
Uh-huh.
And she's like, well, if this is real, where are the stars? Like, that's the first thing she opened with.
Well, like, I mean, Paul could show her the stars like in 10 seconds
if
she really wanted to see him.
And then she went on this tirade about if it was real, if all this space junk was around in orbit, it would fall back to the Earth, and it would hit things. And I'm like,
a lot of it does, and sometimes it has. I mean, all those things are true. If only she would. Or is that she? Did you say it was a she?
I believe it was a she. Yeah.
Oh, okay. Well, I mean, people don't understand space. You know what? You take them away from looking over their steering wheel at the road, and they're out of their element.
Yeah.
That's the trouble.
But I don't know about you, but if it's something like I don't know about, like I'd be kind of, hesitant to make a public comment about it.
If you think you have an idea about something, like people, there's people that think that, the government was entirely responsible for 9/11 and that the shooting in Newtown, Connecticut here didn't happen.
Yeah.
And of course that's ridiculous. I know state troopers that were on scene for that shootout and they saw the bodies of children, and they were done in for months. They had to sequester themselves.
I don't think it's letting me add Amanda because she has a do not disturb thing. I tried twice now and it won't let me add her. It keeps trying to dial her in, but it won't. So Amanda, if you're listening, you might have to take it off and just put it on away status or something like that for me to actually add you to it. Just an FYI, because I tried calling her twice and it didn't even act like it was ringing her. It just had that little connecting dot, and then it just cut off.
Yeah.
So what's going on, man? What's been happening the past couple days?
Yeah, I've been writing the script for Sunday's show, for the radio show, for Sky Tour Radio.
Dude, that hour goes so quick.
It does, and they're already talking about extending us to 2. There's a number of people that want to see us go to 2 hours. Actually, quite a few, and we can do it. We can really do it. I mean, last week our show was number 2. It was ranked at number 2, so I thought that was pretty good for the 9 to 10 slot on Sunday. And I'm amazed at that. I can't believe it. Because we were number 3 before that. We were number 3 for 3 weeks, and then number 2 for the next 3. So it's this is crazy. I mean,
who was number 1?
Somebody I don't even know, but it was this was on TalkStream Live, and it was ranked against all the talk shows that were running from 9 to 10 in the evening. And of those, I mean, we climbed past everybody pretty quickly. KGRA tend to do well anyway,
Right.
And I mean, it's not all about ratings. It's all about getting the information out there and doing the right thing, and that's all we're doing.
Mm-hmm.
But you can't help but notice when you're number 2. I mean, that's pretty good. I was like, wow.
You never know.
I'm humbled by that.
Might be breaking that number 1 spot here soon. And Amanda still hasn't changed her status yet for me to try.
Well, I did mention it, or maybe I don't know where she went.
She's watching the Olympics.
Yeah. It's over.
It's turning into a nice night down there in Miami.
Yeah, I mean, it looks pretty stable. Did you see that? I said to everybody in the chat and listening, and watching, I sent Keith a photo I took in the dome the other night, out in the Sky Tour live stream dome, of the moon. Yeah, but I actually sent it to him, and I had actually processed it for real color, so that it actually looked like the moon in real color, true color.
Yeah, that's what I've been doing on the wide fields tonight.
Yeah, you've been doing true color?
Yeah, you'll see it. Actually, I just readjusted because I didn't realize he switched back to the wide field. But on the wide, I don't like doing it on the closer zooms, because then you start getting those color rings around craters because of the white, and it doesn't look as good. But on the wide field, it looks gorgeous.
Yeah, and most people don't realize that the moon isn't gray. I mean, it is in some places, but most of the soil is brown. And that's kind of interesting when you look at it up close.
It's changing.
It looks like
YouTube stream now.
Okay. Yeah, and it's really interesting to see the moon in real, true color, because if you see it in, the regular typical black and white, because people say, well, black and white or true color. It doesn't matter. It's all gray. No, it's not.
Mm.
It's really cool to see it as the true color. And I
Yeah.
think that's what you're changing it to now, right?
Yeah, I just did. I mean, it's not like full blast. It's the best I can do.
No, I understand.
But
I'm not seeing it yet though.
it might be. It has a trouble like on the on my Alien where it has like a cool color scheme.
Yeah.
So it has a little trouble showing up on that, depending on what your temperature of your you have your monitor set and stuff. But
yeah,
on the big computer it looks really good.
Okay.
But
I should be in. This is 1080. I got this in 1080.
Yeah, if you're around the 10-minute mark on the atomic clock up in the left, then it's on. So I'm not sure if you're seeing it or not. You can definitely tell the browns to the left-hand side.
Well,
more
mine's. Well, hang on. Wait a minute. What's going on? I was stuck at 9:56 and 29. That's why.
There you
go. I wasn't live. Still not.
Son of a bee.
How come the clock's not counting up?
You have an internet problem? Well, I don't know, because you'd only dipped out once since I've been on with you. And we're totally going to put that towards weather tonight.
Yeah, no, we have problems with weather sometimes. All right, I'm just going to refresh.
Yeah, she's still...
Oh, yeah, see, that's a little more like...
yeah, you can see it.
A little more true color.
Yep.
Yep.
Who do we all got in the chat tonight? Let's see. I'm just going to go down a participant list, so if you're not on that... Doesn't look like there's a whole lot of participants in the chat. A lot of people watching anyway, so thank you to the people that are watching and letting us use your eyes.
That's right.
We have Gio and Nathan and Rod and Sinner7 and Doodling.
Doodling Panda.
And the real Jimmy Roberts, who has a really good channel. Actually, I checked out the other day. Interesting stuff there. So check out Jimmy's channel if you want something to check out. And of course you got Tim, and you got Timmy Chunga, and Zombie. So those are the people that have participants.
Zombie Nomad.
Zombie Nomad.
Cool.
I guess Amanda fell asleep.
No, I was just talking to her, and she said, "Give me a few."
Oh, okay.
And now she hasn't responded, so I don't know what's going on with it. It's okay.
Do you have... Well, I think Dee was in here earlier. Where's Dee at?
She might be still watching.
Dee, if you're watching, let me know. Because I'm going to bring you in here, whether you
Look, Amanda just went into chat.
Yeah, I know. What? No, she just dissed us. Can you believe that? I tell you. Thanks for dissing us.
Who are we growling at now?
We're growling at you.
Well, if Mark would ever learn to read all the messages I sent him.
I did. You sent me. Leave me. You
what was the last one? What was the last one?
Give
After
me
you
a
said
few.
Keith will bring. Thank you.
You said give me.
So I come back, and if you have a message saying, "Take off Do Not Disturb," Keith tried calling you twice. Well, I know, but I was away for a few. Remember?
Yeah, but what's a few?
I'm here now. Hi, all.
Okay, now we're going to shift the blame to Mark. Darn you, Mark.
What's a few? Give me a few. A few what? Grains of sand? Moments? What? I mean, a few what? You're supposed to say, give me 4 minutes and 30 seconds.
Well, not all of us are that technical, Mark.
I know.
Like, hey, man, I'll be back in a few minutes. Mark will be like, I'll be back in 3 minutes and 32 seconds.
No, I wouldn't do that. I would never do that.
But then he forgets about you the next day around noon.
I'm the same way, though, because you know what?
I've done that to her.
When I shut the Skype off, like from the computer, I have it on my phone, but for some reason my phone doesn't alert me to messages, so I don't see messages until I actually log back into the computer and all these things pop up. I'm like, holy crap. Like all these people, like you guys the other night, all three of you, trying to get a hold of me, and I'm like, what is going on? The next day when I actually see
I thought you were sleeping.
I was.
Yeah.
That's what I'm saying. When I logged onto the computer... If my phone would have alerted me, I would have seen it that night. But when I logged in the computer next morning, all of a sudden all these messages popped up from all three of you. I'm like, what's going on now?
Nothing.
Yeah.
So...
Yeah, but you were on Do Not Disturb, so the three of us shouldn't have been ganging up to disturb you.
I always have it on Do Not Disturb.
And I always forget to put it on Do Not Disturb until I actually do the show.
Yeah.
But, I'm going to thank you, Keith, for letting Amanda and I come on. Amanda and I, of course, are Sky Tour Radio on KGRA on Sunday nights, 9 to 10. And Keith is streaming every freaking clear night with Paul. I think it's great. And are you going to tell people about the new stream? Have you talked to them about that yet?
Nope.
Okay. I will not break the news.
No, yeah.
Is that a secret / surprise?
No.
Yeah, sort of.
I actually mentioned. Mark, we talked about it the other night, actually, when you were on. We got the...
on the air?
Yeah, we got the microscope streams.
With the microscope. Yeah. Oh.
And I will tell you, Mark, that the microscope is here, and it works fantastically.
Good.
I am just working.
So we made a good call then, because we were looking at them online together, you and I. So that was a good one.
I think I'm still going to get like a backlit one for the future, just in case we want to look at any liquids and whatnot, and go on the cellular level. But yeah, this one's definitely going to work out great for the first things. Yeah, and I'm thinking, since it's here, and if I can get everything set up through the computers and whatnot by Sunday, I'm thinking about maybe doing the first one Sunday. So we have that.
Don't do it from 9 to 10 in the evening. That's all.
No. It'll be daytime.
Yeah, you can go daytime with those.
We might do them Sunday afternoons, or around noon on Sundays, because what I'm thinking is we might go from the microscope stream right into the solar stream.
Oh, that's neat.
That way we can kind of make it a dual thing. So what we'll do is we'll be looking at stuff through a microscope for like a half hour or so while Paul's setting up, and then we'll go right into the solar stream of the sun. And hopefully it's a little more active than it was over the summer, because that sucked. There was like nothing going on the sun.
Well,
there was no sunspots. There was nothing. I mean, it was at the solar minimum, right? So.
Yeah, it's quiescent because of the solar minimum, but that's okay.
Yeah.
I mean, because then you get the total surprises where people are seeing they're seeing like immense auroras like we haven't seen in a long, long time.
Right.
I mean, that's pretty cool. I like a good auroral display. I saw, oh man, the best auroral display I ever saw was right here in Connecticut. In fact, 1 mile from my current house, exactly 5,280 feet, is my other house I had just before this one. And it is exactly that distance. It's really crazy.
You know what, Mark? And hold on for a second. I'm gonna interrupt you just because I'm gonna tell you to shush for a minute, because I want to talk to Amanda.
Okay.
Uh-oh. Well, you know what? After that, I want to talk to Paul.
You can if you want to. I want to talk to Amanda.
I don't know if he's listening, but if not, I have a message for you to pass on to him.
Okay. Just let me know whenever. Okay. But no, my question for you is, how are you liking doing the radio show?
I do like it. I'm always nervous every time, but that was the same as when he went live on YouTube.
Right.
I have no notice or a week's notice. I just get... I don't want to let anyone down, and I don't know anything about this, so I think he could have found a better host for the subject.
Here's the crazy thing. And this is something personally just from me as an outside perspective have noticed, is that you have really come into your own when it comes to doing this. Even when I started with Bill, you can tell that not only are you Mark's co-host, but you're also, in a way, Mark's student, and you're picking that up. You know what I mean? You're learning like more and more every time, and more where I've noticed that you're giving a lot more input, and it's the correct input, and it's input I don't even know. And I'm like, wow. I was like, she's really been going to town with it. She's really absorbing that information. So it's been really great to see that evolution of you from, 2 years now to where you are now. It's absolutely great. I think it's wonderful, and I think you're just going to keep on going that way, and then before you know it, we're going to have 2 experts.
See that?
That is so kind of you to say. Thank you so much. I think that's half the frustration, because with the amount of time you do spend repeating yourself and using analogies and helping me get it, it's so much information that I don't know. Like, I really had no basis in this to even work on. So this is really the foundation, but I'm getting it. It's just, then I'll ask a question. It's like, we've been through this like 5,000 times, and it has to click, but I think I'm starting to get... I was thinking about that last night, the HR charts. I think one side's the spectrum, and blue is the hottest and red is the coldest, and then the other is the luminosity, and they go in Roman numerals.
Mm-hmm. She's an astronomy teacher already, and she doesn't even realize it.
See, so that's kind of right.
This is what I'm telling you.
If I can explain it basically, then I know other people listening are getting it, because
exactly.
I find the people listening to like this show, to Mark's show, drop by Bill's, drop by Chris's, who is streaming as well at Take Back Space.
Is he streaming right now?
He is.
Oh wow, 2 nights in a row. Awesome.
And he's a wonderful musician, a wonderful vocalist. He writes a lot of his own music. I think he has 3 albums out now, and so you can check that out. Take Back Space.
Yeah, definitely
YouTube.
A channel I would recommend. If you haven't checked it out, Take Back Space. He streams over there in 4K. He doesn't get quite the close-ups that we get, but the 4K and his total moonshots, and even when he zooms in with it, are outstanding. And then you can go over there and listen to good tunes and whatnot. A really good guy, a really good astronomy channel. I definitely would recommend it.
And he knows his stuff too.
Yes.
And like I said, the people that kind of gravitate towards that, they either have a basic understanding or do this as a hobby themselves. So I feel like, you know, someone's coming for an astronomy lesson and then they're listening to this girl fumble all the analogies and mix everything up. But if I can get it, anyone can get it. And I am getting it. So that just shows what an excellent teacher Mark is. And I don't care. Like, talk to me like I'm a 2-year-old. I don't care. You know, the analogies are what makes sense about putting dots on a balloon and blowing it up, and that's how the space expands. And
I'll tell you what, like, this is where I'm going to blow smoke up Mark's you-know-what.
I don't need that.
Well, listen, this is where you separate yourself from others. Because you take a complex subject and complex, areas of astronomy, and you bring it down to where everybody can understand it. Mm-hmm. And that is your gift.
Well, that is important, right? I mean, isn't that what you're supposed to do?
Absolutely. I learned so much from you. It's mind-blowing. You know what I mean? Even from where I was 2 years ago to now. It's just, you have that ability to do that. And when I know we've always told you that, between myself and Bill and Amanda and, everybody else that, so being the fact that you now have an outlet on a radio show, your own radio show where you can pick the topics and stuff. And I think it's just good because it gives a little, I don't want to say anything against KGRA, but it gives a little credence to KGRA. Where it's given that scientific point of view and not always the conspiracy point of view. You know what I mean? It's a give and take. And I think you even that out perfectly by, number one, not being a rabid debunker. Where you're actually, but also somebody that's going to look at the actual science. And I think that's a good level playing field for KGRA, and I just think it's great.
Well, I have to say, KGRA did agree and did want me to be on their station. They did want it. They brought me there. Right. And it's Thanks, not Jimmy. Like I went to them saying, please can I? They actually thought of me and they said, hey, let's get him on the air. Let's get him on his own show.
Well, I mean, you might as well. You were on like everybody's show anyway.
I know.
You know what I mean? It's like, why not give this guy? I mean, everybody wants him on their show to begin with. Why not just give him it's the smartest thing Race could have done. Truthfully.
Yeah, I think that it's going to be good for them, And the thing is, I'm still on other shows, and I still have, like, for instance, on the last Sunday of every month, I'm on Commander Cobra's show for the last half hour, and then I just go right into my show. Right. So I think it's kind of interesting because I get out with Cobra, and we just talk back and forth about anything. We talk about the mosquito squadron restoration they're doing. We talk about some of the exoplanet science that is the latest and greatest, and sometimes we talk about just other things, just shooting the bull.
Right.
But then we go into our show, and we actually have an agenda for our show, and that's to kind of set some basics down for everybody that they can then go back and listen to in the archives.
And Jimmy just said it in the chat. It's a perfect wording. He said that anytime someone takes an open-minded scientific approach to something like this is a great thing. I appreciate the effort. And once again, if you get a chance, check out Jimmy's channel. It's definitely interesting. I spent an hour or so there the other day watching all the back videos, Jimmy. Good stuff.
Cool.
Yeah, it's a good channel.
Yeah, and as more people, as more people get able to do this, and some of us get the ability back to do it. Yeah, I know. I'm still.
I'm debating. I'm debating whether even to bring this up. I don't know if I should.
It's
about our buddy.
Who?
Mark.
Well, you don't have to mention his name, do you?
Oh, I do.
Maybe all right. Well, you know what? You just say
I'm dying. You have to tell us.
Mention the problem, and then let people see if they can figure it out.
Well, it seems like our friend, another moon streamer, has gotten himself back into some drama, which we knew was going to happen eventually. I can mention the other channel, though, because I got to set something straight. There is a channel on YouTube, and I don't know if you guys have seen it, but I'm sure people in the chat have. There's a channel called Bruce Sees All. Okay? And I'm pretty sure you've seen all this. Now, I think what Bruce is doing on a personal level is great. He's going out. He's putting the work in. He's doing... Now, we might have a difference of opinion on what he is interpreting from the data he is receiving, which is fine. That's no problem whatsoever. He can interpret it however he wants to. But he's doing really good stuff, and it's one of those guys. I believe he's truly honest. I totally believe that he is looking for some kind of truth. And I do think he has a great channel. As I said, he's putting the work in, and he's doing it. Now, once again, we differ on the meaning of that work. But there is another YouTube guy that is really crawling closer and closer under my skin. Because
tell us all why.
what he is doing is he's doing the same thing that he did to us, per se. Okay.
Yeah. Was this name mentioned to me just recently, Mark? Again?
It might have been, yes. And
three words, three names.
Yes.
Oh, what's he doing, Keith?
And I noticed that he started this with Bruce. And as soon as I saw that comment, I'm like, oh no! I was like, he's gotten to another one.
What did he do?
Now, once again,
didn't see this comment.
I might not agree with how Bruce is interpreting his data and whatnot, but I totally 100% support him in doing what he's doing. I mean, he's got his stuff together. He got Patreon donations for now. He has a nice 14-inch HD scope that he's going to be putting to the test. I mean, that's great. He's doing great imaging, and it's a great channel. But I knew as soon as he would do that, and as soon as he started getting really good moon images, this person would come into the picture.
Surface. And what did he do?
My God, he did.
And what did he do?
Somebody, I guess, made a comment on his channel about,
channel?
Hey, on
Bruce's?
On this astronomer's channel, if you want to call him an astronomer.
Oh, okay, the other guy.
That said something about going over to Bruce's channel and siphoning money and people from his channel, since he was going to become popular with this big scope that he purchased and whatnot. And Mr. Astronomer guy, of course, loved the comment. Basically, like he's like giving permission for people, and then anybody that would bring up Bruce on his channel, they would get reamed out. For being supporters of Bruce and not this other astronomer. It was just he's pulling his crap again. And for anybody that doesn't know who I'm talking about, I've talked about this before in the chat. You can go on Above Top Secret ATS and read all about the shenanigans. But it just seems like drama follows this guy everywhere. And I can tell you why, because he wants to be the #1 moon streamer on YouTube with the optics that everybody's begging for. And that is his drive. He did it with us. He did it with Dark Skywatcher back in the day. And now he's starting to do it with Bruce. And it's just, I don't know. Putting the warning out for anybody that starts streaming, if you get halfway decent optics, you're going to deal with this guy in one way or the other. And I'll let you guys figure out who it is. I'm pretty sure most of you have figured it out anyway, but had to get that off my chest. Because you gotta, guys, we're not debunkers here. We are not debunkers. Mark, you agree with that, correct?
Yeah, I agree with that.
We like scientific data to back up what we see. We know how optics work. We know the ins and outs of what we're seeing. That being that, I think Bruce is, once again, he's interpreting it how he wants, and that's fine, because the way I have always saw this channel and other moon streaming channels is the more eyes the better. I've said this since day one. Whether you're watching us, whether you're watching Mark, whether you're watching Bruce, even if you're watching that other astronomer, not to be named, the more eyes the better, because the more eyes we have looking at the screen or actually out on telescopes, the more chance we'll have to see something. And that's the goal, right?
Yeah.
I mean, that is the end goal, and I'm pretty sure it's the end goal for every other astronomy channel on here, especially if you're just gazing at the moon for hours at a time. And we've seen some crazy stuff. Some stuff we can explain, some stuff we can't. By the way, the other night, did you get the angular for that object?
Oh, actually, you know what the thing is? I have it up right now, actually. And explain to folks what I'm going to do, so I can so it sounds, so it makes sense.
Mm-hmm. Go ahead.
No, go ahead. You tell me. I'm looking for it now.
That was your setup.
The other night,
nice throwback.
Yeah. Well, I thought the other night we had something come past the moon, and it was pretty visible. Now, obviously, when it passed, I said it was in shadow because it was a dark shadow. So that told me personally that it was in Earth orbit, and not getting the sunlight. But what Mark does is he actually has a formula now. And do you do it through the computer, Mark?
I do. I wrote a program to do it, actually. It's a real simple thing.
Where he can... I'll let you explain how it actually works if you want.
Yeah, and basically it takes the... basically, if you get the length of a trail that something leaves on the image... Now, the moon is 30 arc minutes in diameter. Okay, so just about. So, and 30 arc minutes is basically half a degree.
Right.
Okay. And in that time, if something passes across the moon, that's the same thing as doing a exposure, all right, for however many seconds it took to go across the face of the moon, all right, over a length of a trail of it moving it, which is 30 arc minutes. So based on that, if there was a object that, say, took 27 seconds to cross 30 arc minutes, okay, then we can tell right away that it has an orbital velocity of 11,301.915 miles per hour, and that's basically 5,052 meters per second. And the altitude above the surface of the Earth for it to be moving at that speed is 5,755 miles above the Earth. Okay, so this program, basically, we can use actual satellite trails on footage, or we can just take a image of the moon that has an object passing across it, and if it's a small section of the moon that it crosses, we can extrapolate how long it would take to cross the full distance, because we can measure how far it went in that many seconds. And if that's less than the 30 arc minutes, we can just pad it out to what we need to make it, what it would actually have been if we saw it across the face of the moon. And then we put in those two numbers, and we get our answers to how far and how high it was.
Right.
So this last object, this from last week, I think we were talking about. I think we figured in that 30 arc minute length. I think that the time it would have crossed the moon in that time was approximately 12 seconds. I think, if I'm not wrong. Mm-hmm. I'd have to go back and check again, but that would put it at probably a booster, a satellite booster that's 1,698 or 1,698, almost 1,700 miles above the Earth.
Which would put it in, let's see, you said 1,700?
Yeah, it'd basically be in a fairly high Earth orbit. And it was a north-south movement, wasn't it?
That's still low Earth orbit, but, yeah, it was definitely linear. It was, straight on. So if you go 1,700, so most likely you're looking at either a global star satellite, you're looking at Russian military defense satellites, or right around that general distance.
Well, don't forget, I mean, it was a north-south orbiter, and most of the defense birds are the north-south orbiters.
Mm-hmm. And then, so that would be my guess. The only other ones in there, there's a couple from the People's Liberation Army of China, but they're a little low. They have about 1,000-kilometer range. So,
well, I'm talking about miles. This was,
oh, you're talking about miles. So
yeah, 1,600, almost 1,700 miles.
Okay, so
not kilometers.
Kilometers
miles.
Would be. Help me out here.
You don't know how to convert kilometers to miles?
Not in my head, I don't.
Oh my God, what is wrong with you? For Christ's sake, can you you can't just figure this stuff out, huh? Okay, 1 kilometer is 0.6 miles. Okay, that's all you gotta do.
All right, I'm already lost.
All right. Well, if you have something that's in kilometers, right? All you have to do.
I got a crazy idea. Why don't you just tell me the answer?
Well, I don't know the answer. What's the number?
You just said 1,700 miles.
Oh, 1,700 miles. Okay, so 1,700 mile height. Yeah. No,
what is that in kilometers?
Oh, okay. Well, I'll just multiply to get it exactly.
All right.
All right. So the answer is, so if we're looking at that for the satellite, we're talking about 2,735, 2,736 kilometers.
2,700. Wow, there's not a lot in that area. The only one that's coming up for between 2,000 and 3,000 is a Russian satellite. Now, of course, if it's classified satellite, we wouldn't see it, but but that one, if it is that one, it was launched on December 25th, 1994.
Yeah, see, we can do this reverse engineering and figure all these things out.
Yep.
Oh, and that's what makes sense. Now, the other thing is, it might have been at the low end, it might have been 9 seconds to cross the moon, because I couldn't. It only was there for a fraction of a second, and didn't see it on the dark side. I had to extrapolate how much of the dark, unlit portion was there. And if it was only 9 seconds, then it was only 711 miles above.
And that puts it in with all kinds.
Yeah. Okay.
But you said
711. It's 1,144 kilometers. So that's actually a lot.
Yeah.
That's quite a lot of regular satellites. Now, keep in mind that geostationary satellites are 22,000 miles plus out. Okay. So even a geostationary transitional booster trying to get something into geostationary orbit is going to be a lot farther out than 1,100 miles and 1,200 miles.
Well, geostationary is around like 35 to 38,000 kilometers, right?
Kilometers? Well, yeah, I'm in miles. I'm always talking miles. So yeah.
So
it's like 35,400 kilometers roughly for geosat.
Right, because I think doesn't the radio satellites, they're a little bit further out, if I remember correctly. I think
maybe. I'm not sure where all the satellites are, relatively speaking, but I think that it's important to recognize that these satellites are there for a reason. They have to sit over the same part of the Earth all the time.
I'll tell you what, Mark. I actually answered this earlier, but I'm gonna see if you know, just to test your knowledge.
And
don't worry if you don't know, because it's not it's not a common knowledge or a study knowledge thing. But what is the furthest satellite orbiting Earth? How far out is it?
I know that one.
Well, are we going to talk about
not natural satellites?
Right, not the natural satellites, but I mean, we're talking like, if we're going to talk SOHO, I mean, we're talking SOHO.
A man-made satellite, the furthest one orbiting Earth.
Yeah, the Solar and Heliospheric Observatory.
And that is how far?
About 1.5 million kilometers for you. Mm-hmm. Okay. It's at a Lagrange point. So, that a Lagrange point is that point where gravitational forces are balanced between the bodies that are interacting with the object, so that it can kind of hold station with relatively minimal efforts.
Okay. And then what's the next one?
Probably another Lagrange point. I'm not sure about that.
All right. Well, I'm just going on basic. I didn't really actually want to go out to Lagrange. I'm talking about between the moon and Earth, but still, that's an interesting fact, and now I know that. But
yeah, SOHO is 1.5 million kilometers away. I mean, that's
the furthest
that's quite
one
a far
currently,
away.
If you want to stay within Moon's orbit.
Okay, so out to 240,000 miles or less.
Well, you're looking at about 330,000 kilometers. So,
okay.
We are looking at it's a multinational, so it's for space science reasons. And the owner of it is Astro Space Center of Moscow, Russian Academy of Sciences. Classified as a government
205,000 miles, huh?
It's out there.
Huh.
Yep. Amazing.
Well, I mean, I did know about SOHO because SOHO is, I was going to ask you about Lagrange points, but for those that don't know,
I should have specified.
I just mentioned Lagrange points are that's point where the gravitational forces are balanced, and any satellite out there, it'll be tugged and pulled a little bit, but to hold station, it doesn't have to do much because the forces of gravity on all the bodies pulling on it are relatively the same from all sides.
Right.
So that's sort of a interesting location. We'll
say goodnight to Tim. Tim's heading off, so goodnight, Tim. Also want to say Nancy had sent me a picture of her and her P&K shirt, which is awesome.
Nice.
So if anybody else wants to...
Can we see? Are we allowed to see that on screen?
I wouldn't do that without asking her.
I don't
know if... I know. Well, it's on my Facebook page if you really want to see it. I don't know if you can get it
I will. Okay.
But
I will.
Yeah, so if anybody else order shirts or whatever, when you get them, if you want to shoot a picture over to the Twitter or the Facebook page, that'd be cool. Once again, we just figured we do that just to we do the shirts just at least so you get something for.
I like that shirt. I like the way it fits. Beautiful picture, Nancy, if you're listening.
And welcome
love that pic.
To Jenny, who decided to pop in out of nowhere after such a long time. I missed this one. She hasn't been here in a while. I do see her on Facebook, though. But
cool.
Yeah, she hasn't popped in the stream in a while. So hello to Jenny.
She's been in Germany, I believe.
Well, she was in Germany back last year at some point, right? Or did she go back again?
I don't know. I feel like I've been out of the loop for a while myself, so.
Rod says, please, can you someday direct your telescope to Mars so we can see the unbrushed version?
The unbrushed version?
Okay, Keith,
yes.
If Paul's listening, can you let me know if he responds to me?
I don't actually think he's listening.
Okay, well, Paul and or Keith, is there any chance of either shortly after sunset seeing Venus and Mercury, is it? Venus and Mars just after sunset, or just before dawn could we see Saturn?
Well, here's the thing. We're starting the Saturn and Jupiter streams next month because they're slowly making their way into our night sky. Into our, they're there now, but it's like late night, like early morning.
Yeah, like 4 a.m. if you want to go out and...
So, starting in about 3 weeks or a month or so, they'll be starting to come up around 10:30, 11 o'clock, and they'll, slowly get, earlier and earlier and earlier, where they're going to be, right at, or, the zenith, prime time. And we'll definitely be doing those streams in between the moon cycles. And even probably taking a peek at them during the moon cycles.
Okay, hold on. Yeah, Venus and Mercury are about 20 minutes after sunset, and Jupiter, Mars, and Saturn are first thing in the morning, southeast to south, or south to southeast.
Mm-hmm.
So
you're asking, can we do that?
That's happening now. That's like happening over the weekend and into next week. Is there any chance of that being streamed? Like I know you guys were going to do the planetary ones up soon, but
right.
This one's like kind of a conjunction, so...
Here's the thing.
Mars,
yeah, Mars kind of just looks like a red dot. I mean, yeah, we'll take a peek at it, eventually. Okay. But they're not, when it comes to, it's just, they're not really interesting.
Well,
they're interesting in their own right, but, it's just...
Mars has to be at, has to be close by. It has to be close to us. Yeah. If it's close to us, then
I thought if we could see it with the naked eye, it would be great to capture them all hopefully in one shot. No, rather than a close up on one distinct planet, which is cool. Don't get me wrong, but
take a look at this screen. Okay, we're looking at the full moon, and the full moon is taking up half a degree.
Yeah, but it's zoomed way in.
No,
back up and see the whole moon.
I think this is. We're seeing the whole moon now, And this is basically a half a degree across. The field he sees is half a degree in the horizontal. In the vertical, it's less. So the question is, if the planets were near each other, less than a half a degree, then you would see them. And you could see them all in one view. But that's usually not the case. In fact, that's very rarely the case.
Well, so that's why I'm asking.
No, that's okay, but that's okay.
It would be cool. It would be very cool to see.
You can pull it out and do like a kind of a wider field of catch them both, but
yeah, that's what I was thinking.
Kind of looking at a couple dots.
Yeah, that's true too.
Yeah, but Saturn, I mean, Paul is itching to put that 12-inch to the test.
I bet.
So, yeah, I mean that's gonna really be good when it comes around to the Jupiter and Saturn streams. Because what we did last year with the 9 was just amazing, especially on the calm nights. You know, we were getting really good imaging of those two, and now we're going to add some more photon gathering to the arsenal. So
that's right. Light gathering power is all good.
Yeah, so it's going to be pretty interesting. I think we're going to go to like 11 o'clock. I think Paul just texted me and said he's going to go to around 11. So just so you guys know.
And I'm sure this has been asked a gazillion times in your chat already, but I have to ask because I'm curious. Can you see Elon's car?
Oh, that's been asked like a zillion times. No, actually, you'd have to do it.
It probably has been. I just haven't been around since the car was launched into orbit.
Too far now.
Well, the thing is, though,
could you have?
Well, yeah, he probably could have but he'd have to do it in a time exposure, like a photograph.
Right.
You wouldn't be able to do it in a live video like this. Not even with our cameras, which we use for Skytour live stream, which are very sensitive.
Over at Astronomy Live, not Astronomy Live Stream, Astronomy Live.
Yeah.
He actually was able to rent time in a observatory out in Australia, and actually tracked it for a little bit. And he actually has the video on his page if you guys want to check it out.
I saw it.
Oh yeah, did I send you the link for that?
Yeah, I actually saw it before that, but yeah,
okay.
I caught it. Yeah, and basically you can see the little trail over the time that he was looking in the field. You can see it leave a streak on the frame.
Mm-hmm. Yep.
Yeah, because I mean we've caught satellite streaks before.
Yeah, but this is a satellite streak that you know exactly what it looks like because it was in Earth orbit. That's all.
Right, and he shows you exactly how he did it, how he tracked it, all the math that went into it, and all that kind of. It was really neat. I mean, as I said, Astronomy Live, he's like Mark, one of the smart guys I look at, and he makes it look so easy, but then you look at the work that he did, and you're just like cringing, going, "How does he even understand that?" And I'm pretty sure you understood it perfectly fine, Mark, but being that you worked in observatories and whatnot, but I was like, "Oh my god."
Everybody has their own things that they do that they can do, like that's what we call like rolling off a log, like really easily.
Right.
But in his case, he was able to do that projection on the sky, figure out where it was going to be. And I didn't do it. He did it, and I thought it was great. I loved it, so I gave him kudos for that. I thought he did a great job.
Yeah, if you guys want to see a channel that's definitely straight to the science, let you know how stuff works, Astronomy Live is definitely a good channel to go to.
Yeah.
Amazing.
That's right.
And he does some crazy stuff too over there. I was telling you about the one time he went in with like a 3D measuring device and measured the spacesuits because he was trying to debunk how people were saying that the spacesuits didn't fit through the capsule doors.
Yeah, right.
So he went in and measured all that stuff. He measured the capsule door just by standing in a museum and pointing this laser measuring, it measures with dots and stuff like that. I'm not sure exactly how it works, and he gets a 3D image of it that way and then is able to put it to it. It's crazy, but it's awesome at the same time.
Yeah, no, I think that's great. That's just using tools to do it, do exactly what you want to do and do it right, and that's perfect. And see, no one can argue with that. No one can say you fudged the data. Yep. Well, no, this is the actual data right off this, and you can check my data. See, that's the benefit of this, Yep. And that's why, that's a true scientific experiment.
Yep. And that's what he's all about, the scientific data to back it up.
Yep.
There's a question for you, Mark. It came back a little while ago, though.
Okay.
But I think it'll still be appropriate, I hope. GeoVS20 asks, what is your understanding on these octagon craters?
Oh, you mean on the moon?
Yeah.
because
it must have been something we were actually looking at the time, but has since moved. So, okay. Octagon craters in general. What do you know?
Well, what's interesting is when an impactor hits the moon, it basically, you can think of it this way: it liquefies the surface for a short period of time. So it's as if the surface is liquid, and you'd actually see, if you could see it live and in slow motion, you would actually watch ripples moving out from the center of an impact that look very much like water ripples, but it's not. It's just the regolith, the soil on the moon, acting like a liquid because of the impact and that instantaneous vibration. So those conditions sometimes will set up some types of geometric resonances where you might actually get an octagon crater, or a hexagonal-looking crater, three-sided crater, triangular crater, and of course, it all depends too on the angle of impact, the speed of the impact of the impactor that's hitting the moon, the composition of the impactor, and some of these shapes can be pretty far out. And when people see octagons, they think, oh, see, that's not naturally occurring, but in fact it is. Hexagonal craters, that's not naturally occurring, but in fact it is. The pyramid's a naturally occurring shape. Okay? But, that doesn't mean that the pyramids in Egypt were naturally occurring. They weren't. Okay? Over time, they were actually constructed, of course. But the shape of the pyramid is something that is well known as a landform to exist elsewhere, not just on Earth. So there are some geometric shapes, that are what should I say? That we'd find on the Moon, on Pluto, Ceres, and other places. So it's a pretty well-known science, but nonetheless, it's still pretty exciting to see these things. Mm. So I mean, and I guess Tana has asked me a question about, have I ever seen a white hole? Well, I mean, I want to answer that without making a joke, of course. But let's talk about black holes and white holes, okay? A black hole obviously everybody knows a black hole as this area that's has such a heavy gravity, heavy duty gravitational forces that not even light can escape it, which is interesting because it implies that light has mass, because gravity affects mass. And that's true. Okay, an individual photon of light, a little light packet, right, light particle, actually does have a relativistic mass, which is kind of cool. And it can be stopped and bent by gravity. That's why gravitational lensing works, for instance. Well, the black hole is an interesting thing because obviously I won't get into how they're made. I could talk about them, and we could talk about that Schwarzschild radius and all that stuff. But the fact is, once you have a black hole, there's a certain point of no return. That point of no return is called the event horizon. Once you pass the event horizon, which is a very turbulent place, it's heavy-duty magnetic fields there, very, very, very turbulent area. Once you pass that as light, you can no longer get out of the black hole because the gravitational forces will not allow it. It bends you right back around into the black hole again. So what's a white hole? A white hole is exactly the opposite thing. Now, people say, well, is a white hole connected to a black hole? Well, I don't think so. I don't know, but it could be. The theory is that a white hole is spewing tons of energy. All right, and is that what people call a quasar? Well, no. I mean, a quasar is a very bright object, and it's spewing a tremendous amount of energy, and it might actually be the end state of galactic formation, the end state of a galaxy, after the black hole has done this consuming of a lot of the stars within the galaxy. Perhaps it turns into this quasi. It's called a quasi-stellar object, quasar. That's what quasar stands for. And it ends up spewing this high energy. So, although I've never seen a white hole, I don't know that anyone really has.
Giggity.
Giggity good. But I think it's very important to continue looking for white holes because they are the natural counterpart to the black hole.
Giggity.
But giggity, giggity goo.
You have to maintain some level of immaturity.
Of course. Well, you tend to, but that's okay.
Hey, it's something to pass the time, isn't it?
That's all right. I understand.
Any more questions for Mark, since we didn't get to do one after the Sky Tour the other night?
We didn't. That was okay, though. You know, I had, I was tired the other night, and that was no big deal.
So it worked out pretty good.
Yeah. Ted, we had a Quasar when I was a kid. I had one of those cars, too.
Well, the emoji of eyes says, why do all the craters appear to be the same depth and trajectory of impact, which they aren't. But then Michael said, and that is a fact, why some of the huge craters are just as deep as some of the little ones. Can you touch on that? On both of those?
Sure. That's a quandary that many people have dealt with for a long time with the moon craters. They actually look at the moon and say, look, they look so the same depth. Actually, they're not. And on the stream that I was going to do before, that on the very stream that actually had YouTube slap me on the wrist and tell me I couldn't stream anymore because I accidentally uploaded an 11-second video with no sound and no video, and they said it was inappropriate content. Totally ridiculous. But in that stream, I was going to show this very thing because we were going to go through the new Lunar Reconnaissance Orbiter website, the Quick Map, which has these built-in tools. You can go online and zoom into the moon right down to literally half meter per pixel, meaning that you could see things as small as 20, 30, 40 feet across. So good luck trying to.
When I moved to San Francisco with 2 suitcases,
I found it again, Mark.
Oh, hi, Mark.
What was that? What was that you just interrupted me with?
Oh, hi, Mark.
Oh, that guy. Okay, that's the guy.
And I think you hit the wrong button because I saw some subliminal advertisement come up on your screen. Have a second. Oh, you're
no. You
not
know what it is? I have to
me.
because I have pause feed on one, and then I have to because you know how you go down the bottom and it highlights what windows you have open when you hover over the Google Chrome thing. Mm-hmm. So when I do that, and I go up to the other page besides pause feed, it automatically takes both of them off before I click which one I want, and I have no idea why it does that, but it does. Because my screen background on the monitor that I have Paul on, the background, I can actually show you. Let me see here. La 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 la. I don't know where it is. Never mind. But it's actually the P&K emblem. That's why you always see P&K pop up. Because it just takes.
Yeah, it happened so fast. I could just see white, what I'm assuming are letters. Yeah. I'm guessing it was like maybe the K and part of the imaging. Yep. And I only saw it for half a second, enough to know what it was to realize what you did. But
yeah, I'm not sure why it does it. I haven't been able to figure out why it closes.
It's good. Subliminal advertising. It works.
Oh, I don't know.
Anyway, we have another question.
Oh, which reminds me, Amanda, did you see the new shirt?
Nancy?
No, the new one we just did. It is so busy, it's great. Hold on, you know what?
Oh, I like busy shirts.
It's for people with ADD.
And it's freaking great. I had to order me one myself. Hold on, let me put it up on the...
I was going to say, yeah.
On the stream there so you could see it. But, those are the 2 new ones. Oh, no, this is the 1 new one. But it's so busy. But I think it's so busy it's good. And I think that's the last shirt we're gonna make for a while, and then we'll look into doing some other stuff. But yeah, that one's available for the next 2 weeks, and I think it's
still
awesome.
Waiting.
Yeah, it should pop up there shortly. But
so I think a lot of people like the one with the moon on it. Oh, I say, ooh.
Yeah, the one with the moon.
And I almost went to click on it to make it bigger.
Yeah, I didn't have it that big.
Okay, it's not as bad as I thought it was going to be. When you said busy, I was thinking
it's like a
mixture of about 10 tie-dyes. And just like a mash of, yeah.
No, it's just a shirt with a bunch of planets on it and satellites and telescope and.
And if one wanted to purchase one, where would one go?
Link is in the description if you want one.
There you go, people.
They are there.
Link is in the description.
Yep.
We're
gonna do one for Mark too. Aren't we, Mark? He fell asleep. Jeez.
What's that? Oh no, I'm still here.
I said we're gonna do a shirt for you too.
Oh, I'd love a shirt. I have to get one. I have to have one.
I was thinking about making a Mortal Kombat one where it's gonna have like Einstein on one side and you on the other side, and have like the versus sign in the middle.
No, I don't fight Einstein. I embrace him.
You want to fight Sagan?
Well, I mean, there.
Do you want to fight flat earthers?
Yes, it'd be Fe versus Mark. That I could see.
Yeah.
Yeah, I'll take that on any day.
Well, currently I have a friend drawing Carl Sagan for a shirt. That would be the last one that we do then.
Carl Sagan's a good concept for a shirt, actually.
Yeah, he's we're doing he's doing a drawing of that. Will actually work good on the shirt for it, but and it'd be a pretty good likeness. It's not going to be like a cartoony Carl Sagan.
Mm-hmm.
But yeah. So now inside scoop. Anyway,
Excellent.
Amanda,
I love it.
Feel free to continue.
There was, I'm going through stream or chat because I may have missed a question or two. But Ryan wants to know, is it true that the moon looks black and white, but in reality has color to it?
Yes.
Yep.
It is. As a matter of fact, Keith was showing the color moon, and I actually sent him an image I took in the observatory the other day that I processed the moon to look in true color. And by the way, I didn't finish answering that question about craters being all the same depth and so forth.
Oh, good, because there's a bit of a follow-up question to that as well, still from Michael. He also wants to know how you can differentiate each side. How do you know how different each side is of the craters? Of the craters.
I don't know.
Like the outside walls, kind of like.
Oh well, Michael, I don't know.
I assume that's what he means. Like, you know how like if the crater hits and it ripples, and we're talking about the depth of them all, how high would the walls be, and how do you know the difference between each wall? Like more, I don't know, for lack of a better word, dust or dirt came to the right than the left or something. How do you know?
Well, actually,
I'd use that.
If you study the morphology of the craters and you look at how the impacts occurred, you can actually come up with a theory. For instance, if we look at the crater Messier, the crater Messier has this long tail coming out of it of debris that goes distinctly to the left, of that crater, depending on if it's looking at the. Trying to see if I can see it here on this view. I can't really see it here. Keith, you see Messier?
No.
Okay.
Truthfully, I wasn't even looking at it.
All right. Well, it's there. It's on the screen, but it's just very hard to see.
I was adjusting for color for the wide field.
All right, cool. But see, the thing is, Messier has this tail that comes out of it, and so you know that the impactor that hit it came from the opposite side of the tail. All right, and when it struck, more material went to that far side and went behind, and it might actually have been an impactor that grazed the moon and bounced back off and left a trail behind it as it flew by, or it could have impacted. And your other question to answer about the true color, look at the screen now. We're actually seeing the moon in true color, and Keith put it up in true color. The moon is not just gray. There's browns, there's white, there's other colors on the moon. There's darker areas, lighter areas, and it's pretty impressive when you look at it, because you can actually separate out a lot of these different areas by color.
If I go high contrast, I can probably really make it pop, but then our whites are going to be really white. But
well, I think you should do it just to be, illustrative of the point.
There you go.
Because you can also
around
use
105410, it'll go to
okay.
a higher contrast where you actually be able to see the colors a little better.
Okay.
Okay, hold on. I think there's a correction to Michael's last question. I think he wants to know each shot of the moon, like the light side and the dark side. the part that you can see is completely different from the dark side.
Oh yeah, that's.
So he wasn't talking about the craters. He was like, how do you know what's on the opposite side? That's not tidally locked.
Oh, okay. Well,
sorry, Michael. Hope that clears things up. I think that's what he's asking this time.
Yeah, no, I agree with you. And so basically, he writes, I know each side of the moon, like the light side and dark side, the part you can see is completely different from the dark side, and he's not talking about the craters. So what he's saying, probably, and Michael can tell us, is when you look at the front side, that is the side we see, we notice it has all these dark maria, these dark areas. We call them the seas when they're not seas, obviously. They're areas where lava has broken through a thin crust and flooded over the moon in various areas from very large impacts. That's why most of them look circular in nature. Okay, at the top of the upper right here we see in the center, okay, we see it's round and has over flooded into other areas. Okay, those are large impacts that actually did that. Now on the dark side, and that is the side we don't ever see, it's lit up. It's dark right now because it's a full moon, and this side of the moon is lit up. But at all the other times, it's of course lit up as much as this side is lit up. All right, it's just throughout the cycle. So that said, when we look at that far side, we'll actually see that there is a lack of these dark areas. There are no dark areas. And the reason is because of the fact that the moon has a thicker crust on the backside away from us and a thinner crust on the front side. Now, there's a lot of reasons for that, but suffice it to say that it happened, and I've explained how that happened a few times on various streams with P&K, actually. But and I can go into it at some point if you want to, but I won't belabor the point. The bottom line is that thicker crust on the far side means that when an impactor strikes the moon, it's less likely to punch a hole enough to cause lava inside, magma inside, from welling up and forming these gigantic lava seas like we see on the front side. And so we don't have them. So I think that it's important to understand how this all happened, but that's for probably another time because it's really a lengthy discussion.
Get her done.
Okay, hopefully this one isn't lengthy. It's from our friend John. He won one of the 3D printed craters in a KGRA chat a while back. Hello, John. He just wants to confirm, did you say previously that you thought the moon formed from an early Earth impact, or did you think it formed independently?
Oh, I'm on the side of the fence that currently says, or currently thinks that the moon probably formed very likely from an impact on the early Earth. And the problem with that theory, though, is when we look at the moon's composition, the moon's composition is very much like our own Earth. And that's sort of a problem, because if the impactor was, say, of a different object, like a Mars-sized object, a different type of an asteroid, a bigger planetoid, you would think that the moon would be composed of material of that planetoid plus the Earth. But it's not. So that's a problem with that theory of the cogeneration of the moon from an impact on the Earth by an impactor. So that's a little something that has yet to be answered. There's always, that's the thing. We look back in history, we're only as good as the latest data we have to tell us what we want to know and what we can know. We don't know the full mineralogy of the moon. We just know the surface, and we have some ideas about the inside from seismography, from seismic studies. But it's that's pretty cool though, as it is. And so I think probably in 100 years we'll probably have a far better idea, because maybe we'll actually have drilled some very deep cores on the moon by then, and we'll actually have material from deep inside the moon, so we can actually do a geological study of the same caliber that we can do on Earth. But yeah, and Michael, I guess that wasn't his question after all, anyway. So, Michael, think of a better way to ask your question, because I didn't understand what you were asking. So try again, and I'll try and give it another shot.
You'll give it another go.
What?
I said you'll give it another go.
Oh yeah. I wasn't saying anything untrue. It just apparently wasn't answering his question that he was asking.
Yeah.
Okay, and a few people, I know, but a few people mentioned it. Would you like to touch on why the moon is or is not hollow?
Well, I mean, it's obvious that it's not, because of the fact that we actually done seismic studies of the moon, and seismometers left by the Apollo astronauts have proven time and again that the moon is certainly not hollow. Every time there's where people get that, I think that misinterpretation is when they hear that the moon was quote unquote ringing after an impact, and they think that that's like a hollow bell. Mm-hmm. And then that's not what that means. I mean, solid rock can conduct sound waves very, very efficiently, right? And the Earth rings too. When Krakatoa exploded on the Earth, the shockwave from Krakatoa circled the Earth about 6 times. All right. So we don't have a hollow planet. Okay, we have a differentiated planet where we have a crust, the lithosphere of the Earth. We have the mantle, we have the outer core, we have the inner core, and they're all relatively different compositions. So same materials roughly, but different levels of plasticity and temperature. The outer core is molten, the inner core is solid, nickel, iron, and the mantle is more of a plasticky, malleable, hot rock, basically. And then the crust is solidified rock.
We should also make the point that there was never a nuke on the moon. They crashed a satellite.
No, we did. And by the way, remember the L-Cross mission that was looking for water in the polar craters?
Yep, the L-Cross.
Right? L-Cross, yeah. Well, guess what? It turns out that there is more water on the moon than we ever realized. Latest study, and I read this on physics.org, shows that the moon, pretty much everywhere, has water locked up in the crust of the same amounts, or relatively the same amounts, as in the polar craters that are always in the dark. What's that mean? That means that no matter where we want to go on the moon, we will have water as necessary. I mean, that is the coolest thing in the world, because that is basically saying, you have water, folks, you don't have to bring it. You don't have to, spend too much time trying to make it out of raw materials, because there's going to be plenty of it locked up in the chemistry of these raw materials, and you can get it out as a byproduct. So we'll still have to spend effort making it, yeah, but not to the extent that we would if there wasn't any there.
Right.
So pretty cool.
Okay, he says Michael says that's what he wanted to know. If you guys knew about that, they say that another moon backed into it. He's talking about it being tidally locked. Why it moves with us, but we can never see the back of it. Or the opposite side. And I said it's because it's tidally locked. And he said, yeah, that's what I wanted to know.
Okay, well, that's true. In fact, the moon isn't spherical. Michael, that's another thing. The moon is actually kind of oblong. I won't say it looks like a football, because clearly it's not that oblong. But because of that heavier, thicker crust on the back side of the moon, the far side that we don't see, that side of the moon is actually more massive, and its center of gravity is not in the center of the moon. It's actually kind of shifted toward the back end. That said, we actually have there could have been a very real possibility that the back side of the moon would have been the one tidally locked to us. It just happened to be the balance of the forces that won out were the forces that had the near side being locked to us. And why is it locked at all? Well, it's locked because of the proximity of the moon to the Earth. And the fact that it's not exactly perfectly centered, center of gravity, that causes a problem as well. And that's something that that will sort of, I guess, support or result in a tidally locked feature later on. Once all the orbital changes settle down. I mean, the moon was rotating originally, okay, but as it ended up, rotating, there was a denser part of the moon that would rotate past the Earth, and then as it went past, the Earth's gravity would tug on it just a little bit, and it would keep going. Then the next time it come through, it would get tugged on a little bit more, and that oblong nature of the moon, that slightly oblong nature of the moon, reinforced the fact that it was going to end up becoming, or reinforced the tidally locked capability. So that's what actually helped the tidal lock situation for the moon. And so again, it's not even at all. For sure, and so I think that's I think that's pretty interesting.
That and the backside is just so different. Like, I mean, you don't really have the Mari on the backside that you do on the side facing us, and you know, the backside is basically pockmarked with craters. And imagine how awesome our viewing would be, you know, if we had all those craters to look at.
I agree, but guess what? I mean, but here's the oddity about the moon. This is what's weird. The backside of the moon has the highest elevation feature on the moon and the lowest. Okay, the Aitken Basin down south, South Pole is not South Pole, but you know, southern latitudes on the moon is actually the lowest area on the moon and one of the largest impacts. Yeah. You know, and then you have north of it, you have the highest spot on the moon, and it's all on the far side.
I wonder. I mean, you know how they were talking about what was it back in the '80s? Maybe it was late '80s when they were talking about a Mars mission.
Yeah,
maybe it might have been '70s. I'm not sure. How they were talking about launching a rocket to Mars first, and that one would actually make fuel on Mars. That way, they could launch another rocket with the people on it, and then when they got to Mars, they would have fuel to launch back off the planet's surface and actually come back. How does that work? Like, what kind of fuel were they making? And is it possible that they could do the same thing with the moon? I'm not sure what the minerals are on the moon. I know there's going to be a lot of helium-3 that's being hit daily with it, but...
that was actually some of our questions.
Well, helium-3 is not going to be used for a fuel source, I don't think. Okay, it could, but I think that we're talking more about... we'd have to extract oxygen and hydrogen, okay, to make the fuels we currently use. And we would want to, if we wanted to get like hydrazine, okay, hydrazine is a hydrogen and oxygen derivative. So to make hydrazine, we'd have to extract hydrogen from the regolith, from the lunar soil, and extract the oxygen that is bound up with some of the compounds, and then put them together in the right way. You know, not sure the chemistry. I've never made hydrazine because I'd get arrested for terrorism. I made hydrogen, though, actually, when I was a kid, and I made these hydrogen balloons that would blow up in the empty lot next to my house. It was just a magnificent explosion. And, you know, it's like Mr. Chemistry at age 7 to tell you, like, brought the police every time because all the windows would rattle in the neighborhood when these little things went off. Can't do it today, though. But you would actually end up having to make the fuel from that. Right. You know...
but they almost made it sound easy. I mean, is it really as easy as they were saying it was?
You know what's easy? What's easy is if it's in the soil beneath your feet, they call it easy. Okay. Now, because to them it's just a chemical process, and I think that a chemical process means that we're just a chemical process away. You know, from doing you know, a conversion to get it over.
Now, that is a lot of fuel.
Well, I mean, see, let me explain why I didn't say helium-3 it wouldn't be used for rocket fuel, okay?
Right.
But helium-3 would be used for making fusion power plant fuel. Okay, it's more for the futures.
But even still, like even with the hydrogen, I mean, that's a lot of fuel to be made. You know, doing it, you know, shall we say, the old-fashioned way. You know, pulling what you need out of the ground. They almost made it sound almost like too easy for my liking. Like, hey, we're gonna ship this machine and it's gonna do this, and it's like, yeah, but then you need someplace to put all that fuel. You know what I mean? Because I mean, you know, we all know the moon is 1/6, but I mean, what is Mars like, gravity wise?
Is it like, I think Mars is what's the gravity of Mars? Gravity of Mars. I have it. I know it.
It's less than Earth, right?
Yeah, so, it's a third of Earth. It's like just over a third, I think.
That's still a lot of fuel.
I mean, we're 9.8 meters per second squared, okay? And Mars is about 4, I guess. Right. So, but still, that's a lot of fuel. But if you've got a plant that's just making fuel, and putting it into a spare fuel tank that they landed with the rocket, then that's not a big deal. Trouble with that is, though, okay, if you ever notice the rocket launch, what do you notice about the pad? It's always got this leaking stuff, right? It's always got this like steam. It looks like steam coming off of the rocket pad.
You know what? I always thought that was nitrogen.
Off of the umbilicals, right? Well, but what you're seeing is you're actually seeing they're fueling the rocket right up until the moment of launch.
Right.
And then when the umbilicals break away, they've stopped fueling because now they can't obviously go up into space with the rocket. So they stop fueling. They have to keep the fuel tanks topped off because the stuff is volatile. It'll boil away and find ways out.
Well, isn't it true that there is no ignition system either? It's literally when those two chemicals meet, they ignite on their own?
No, they have to use igniters to light the stuff. I mean, you actually see it in the shuttle launches at the bottom. You see those little igniters spewing sparks horizontally into the stream.
Right. I could have sworn.
And then it ignites.
Because, I mean, I'm not saying that it won't. I'm just saying that give enough time, those would actually ignite when you put them together anyway.
You're talking about hydrazine?
I have no idea what it was. And you know, and the thing I was watching was the thing for the space shuttle.
Yeah.
Because it said as soon as they come, they start heating up. But I don't know. I don't even know where I got that from. I could have swore it said when those chemicals mix, they automatically form combustion.
I mean, hydrazine is really toxic, okay? And it's basically... let's see. What's the formula for that? It's actually got some nitrogen in it, and it's got hydrogen... and I'm trying to think of actually how...
Well, what are they using these days?
Well, I mean, it was the aluminum powder that was used in the solid rocket fuel boosters for the shuttle. Okay, and hydrazine's still a popular fuel. But the thing is, to get it to burn, it drops out of the bottom of the nozzle at high speed, and then they have the fuel igniters that ignite it. It's like lighting a jet engine, you know?
Right.
The nice thing is with those, you can shut off the fuel. With the solid rocket boosters, once they go, you can't shut them off.
Right.
You know?
You said that was because of the powder.
Yeah, it's that aluminum cake, that material that goes in there. And I should say aluminum has aluminum in it. But, boy, I'll tell you. It's very toxic. Okay, hydrazine is very toxic.
That's one thing on my bucket list I want to do is I want to get down to a rocket launch at some point.
Oh, I thought you were saying you want to make hydrazine.
No, because I heard there's like nothing like it. Especially now that they're able to land the rockets. I think that would just be totally awesome to get out and witness in person.
Why can't I kill trolls, Keith?
What's that?
Why can't I kill trolls?
Why can't you kill trolls?
Yeah.
Yeah, you can kill trolls.
I can remove comments, but there's no way to ban a user now.
I think you actually have to do it on their page.
Oh, really?
I think. Hold on.
No.
Ted, I'm going to ban you real quick. No, I'm not.
Hey, don't ban it.
I'm just joking. No, you know what?
See, it's only messages.
Well, it gives me a remove option, and it gives me a hide user on this channel. That's also another option. So I don't think it's called banned anymore. I think it's just hide user on this channel. I don't know if you have that option or not.
No.
This user's messages will be hidden. Okay, so they're still there. I just won't be bothered by them anymore, I guess.
Yeah.
We'll see.
Sabine Stanley?
Yeah.
No idea. Some people.
Oh, yeah.
Some people.
I'll tell you exactly. Yeah, it was Saban.
Lamont. We haven't seen Lamont Dixon in a while. How you doing, Lamont? Welcome back.
Lamont had a question, actually.
We have people between Lamont and Jenny and, man.
Yeah, Lamont Dixon had a question about why are there no HD satellites delivering photos of the moon? And the answer is there really are. Okay, I mean, the Lunar Reconnaissance Orbiter has mapped the moon down to literally a half meter per pixel. And you can go see it on the Lunar Reconnaissance Orbiter website. It's called the Quick Map. And you can zoom and zoom and zoom and zoom and zoom as far as you can go until you get down to so close you can actually see individual little rocks on the moon's surface.
Oh, but that's NASA equipment. NASA lies.
Yeah, okay.
Yeah. Who is the one? Is it Japan that has the one that's way out yonder that actually snaps a photo of the Earth every, 14 seconds or something like that? Or is
the Earth and Moon?
No, just it snaps a picture of the actual Earth every 14 seconds. It's like way out there.
Huh.
I forget what it's called.
I think there is one. I don't know.
There's a website dedicated. You can actually go in there and just watch it, as it comes back.
Yeah.
I forget what it's called. I wish I had that link. I would link everybody to it because it's pretty neat. Because if you actually take one of those pictures and save them, which I got bored enough to do one time, and I saved like 100. I guess it was just about 200 pictures.
Yeah.
You can actually get the cloud movement. You can when you put it together. It's pretty neat. Yeah, but it's actually snapping a picture every 14 seconds or so.
Okay.
A high-def picture, too. I mean, high definition.
I mean, we used to have weather satellites that did that. I mean, maybe that's part of that
that's
process.
what it is. I mean, I think it's there to monitor cloud patterns and whatnot. But
okay. I mean, it might be also measuring water vapor and so forth because that's something that.
Well, I'm sure if they went through the trouble of putting that all the way out
Earth.
there, that it does more than just take a picture. I'm pretty sure they got all kinds of bands and different instruments on it. But man, I wish I could remember what that was called. I'm still waiting to hear back from Paul because I know he wanted to end at 11, but I asked him if he still wanted to end, and he hasn't gotten back to me yet. So.
Well, then let me take a chance to answer a couple more of the questions.
Yeah, go for it. How about
Slams Dunk says, "What are the iridium flares I'm seeing?" Well, I mean, if you're talking about iridium flares like in the sky, well, what those are they're called iridium flares because they are reflections of the iridium satellites, and there's quite a number actually, of iridium satellites, and they actually call them. They have a cute little name. They call them a constellation of iridium satellites. And these satellites have a very well-known glare that they reflect back on the Earth. And it's a reflection off of the very bright external panels on this iridium satellite, on these satellites. They're so well-known, in fact, that they program on the Earth. You can write programs or you can look at programs. You can get Go Sat Watch on the Apple iPhone, for instance, and look at when, or even Stellarium now, I think, and other, even free Skywalk, I think, free programs to actually see when the next iridium flare is going to be. And what it is it's the reflection of the satellite as seen at your location on the planet. And basically, that's like, it's like a bright car window in space. Reflecting light back, and you're just seeing that little glint of light off of the window for a few seconds as it goes over. That's exactly what it is. And, it's not a window, obviously. It's a bright silverized panel on the satellite. But that's what they are, and they're very well known, and you can literally have an iridium flare party because you can see probably 4 or 5 a night. And I had a Mars party here one night, and as the last car was leaving the driveway, I looked up just in time. 2 hugely bright iridium flares, one right behind the other, so bright that I could see my shadow by them. I mean, that's how bright they were. I mean, I was stunned. It was like seeing 2 bright headlights in the sky.
Nice.
All right, but it was just iridium flares. So that was cool. But that's what you're probably seeing. And I thought that I'd just let you know there, Slams. And then ERO asked, "Does the moon have an inactive core?"
Could it be the light he's seeing because Keith tried to get it a more sharper, true color image? Well, I see like little flares of light that look like they're reflecting off glass on the moon or something.
No, you're just seeing it. Well, if he means that, well, then he shouldn't have called them iridium flares. But.
I don't know. I just see something like it looks like light reflecting off what we're seeing right now. What's that we're seeing?
Well, I see some because of the contrast, like dead center in the dark areas. I see a little bit of like glimmering, just because.
Yeah, it's almost contrast. Like a reddy, purpley kind of color.
Yeah, it's right.
Looks like little reflections of light. Yeah.
Yep. Yeah, well, that's just because of
actually
the
contrast.
Like if I would lighten it up, which I just did. You would see it. And actually, just because of the way the optics work, because of this custom camera that Paul's using, you can tell when he shimmies the scope, it almost looks like, because of the dark areas, it's an optical illusion. It actually looks like the brighter areas, the gray areas, move separately from the darker areas. Yeah. And it's just the way the camera's picking up. Like, you'll see it right there, because as you can see, I'm circling the what you
it's
call
a
it
slight
now. But you'll see when he moves the scope, it almost looks like two different layers, and that's just an optical illusion. And a lot of people are like, "What is that? It looks like the moon's hollow. That where the dark spots are actually the back side of the other side." But see, you can see it there a little bit when it shimmies.
Yeah.
But let's go back to the big scope. Continue answering questions. I guess he's not done yet, so I'm just going to work on the optics while you educate, sir.
No, but Amanda said that something that needs to be addressed, and I think she may be right. Okay. If he's talking about the bright spots on the moon, then yeah, there's areas on the moon where the sun hits just so, such that a lot of the light from that lighter sediment in that crater is reflected back to the eye, and so it will look brighter. Again, the moon is actually fairly dark, all right, but you don't have a full appreciation of that until you see it in an overall image like this, where you see those dark maria. I mean, look at how dark those look relative to the areas around them, okay? And the areas around them show detail, but the maria show all the detail too. So this is a really fairly accurate view of how dark the maria areas are versus those highlands where there's craters and uplift, all right? And anytime you have an uneven surface, it's going to look a little brighter anyway. So, as far as that goes, that helps to explain why we see these light and dark areas. But now, I wanted to go to ERO's question. He asked, does the moon have an inactive core? And what do we speculate to be at the center? Well, we speculate that, it may be almost solid, but it might still have just a little bit of, heat left in the center. Probably a fair amount of heat, but not all molten like, our Earth's core is solid nickel iron because of the pressure and size over it of the mass of everything. The outer core of our Earth is liquid iron, basically, and nickel. All right. And on the moon, okay, what's important to understand is that the moon is a very different body than the Earth. And because of the fact that the moon has no real magnetic field, the reason for that is because it doesn't have an active core. What's that mean? Well, on the Earth, we have that solid core and the liquid outer core. Well, that solid core and that outer core that is liquid is rubbing against that inner core, all right? And it's basically it's kind of like rubbing your feet on the carpet, okay? It's actually generating an electric current, and that electric current generates a magnetic field, all right? So that's why the Earth has a magnetic field, is because we have an active core, all right? It's a very dynamic core. The moon has no such thing. And so we can tell whether the moon has a core just by examining the magnetic field, if any, all right? And we see, of course, that the moon has a very little magnetic field. So we know that the magnetic, there's no dynamo, there's no inner solid core, outer liquid core on the moon. So it's mostly cool. So that said, I think that pretty much wraps it up, I guess, with that.
I have a question. What's the name of that other site? I just put a link in for the Lunar Reconnaissance Orbiter so people can play around. They wanted to see the Apollo 16 landing site. We explained it's too small, but you can see it there. What's the other one you showed me? I think it might be like 2.0. I think it's an updated version where we were going to like nebulas and stuff. You showed me like a week or two ago, maybe.
Oh, yeah.
You just typed in whatever, and it took like I think we were in Orion's belt, and I don't know if we made it to TRAPPIST, and
we actually this will be a source for our one of our streams. We're going to be going in full 3-dimensional space. We're going to be going to the Orion Nebula and looking at it from inside, circling around the Orion Nebula, and that's a program that's out there that you can download. It's called Space Engine, and it has a lot of add-ons to get. And that's the thing that I'm working on. I'm getting a lot of these add-ons to add to it, so we have it more accurate. But this will give you a tremendous view of the universe in 3D, and that's what I really think is going to be great. And it helps if you have a tour guide, because it helps be able to have someone show you around, like the Orion Nebula. Because then
I'd just be putting in random destinations and not really learning anything.
No, that's okay.
Yeah. What's it called again, though? What's the proper name?
The proper name is called Space Engine. Space Engine.
Okay, I was looking for something else. It wasn't Space Engine.
Okay. Well, we were also talking about planethunters.org as well, and
no.
We're also talking about the LRO quick map, which you put a link in for.
I put that one up. It was another one. I think we may have done a YouTube stream on it way back.
I did do a stream on the LRO. I did a quick map, how to use it and stuff. And then they came out with a second quick map. And when they came out with the next quick map, it's really got a lot of extra cool features that we have to go through at some point. I'll answer John's question, too, actually. He says, I heard that exoplanets have a different distribution in their stellar system from what we have in our solar system, like Saturn and Jupiter disrupted our distribution of mass. Thoughts? Well, we have only had one template for quite a long time, and that is we see our solar system and we say, well, we have rocky planets near the sun, and we have basically puffy atmospheres, the hydrogen atmospheres and methane of these giant Jovian planets in the far solar system. So the thought was that the gases like that were too volatile to stay integral to their planets when they're close to their sun. That was the thought. Well, that thought was actually wrong. And the reason we know it's wrong is, if you watch our Sky Tour radio or listen to our Sky Tour radio coming up this weekend, Sunday at 9 Eastern, with Amanda and I, you'll hear, because we're going to talk about some of that, actually. We're going to talk about some of the newest finds and how some of the planets are actually just so close to their star, and they're actually giant Jovian planets. They're giant, basically Jupiters, hot Jupiters, they call them. And they're very close to the star. So it kind of changed all of our methodologies and our knowledge base. Basically, we realized that large planets like that could certainly exist close to the star, and do. But some can be so close that they are caused to evaporate over time. That is to say, they would leave a little, like a cometary trail behind them as the star starts to evaporate them. And we actually see a couple of planets like that, actually. So it's pretty fierce environments where these planets are. I mean, they, at their surfaces, if there's a surface like somewhere in their middle atmosphere, it's literally raining molten glass. Okay, it's just really just so inhospitable. But as we understand, life will find a way, as I always say, and as Ian Malcolm, played by Jeff Goldblum, will say, as has said in Jurassic Park, life will find a way, and it does. And if there's a way for life to exist there, it'll find a way. It just needs to have a stable environment. It turns out that the environment just has to be stable. It doesn't necessarily have to be hospitable. All right? Black smoker chimneys in the bottom of our Pacific Ocean are stable, okay, but they're not hospitable. So that's pretty interesting, because it just seems like time is really all that's needed for life to grab a foothold, because it will adjust to the conditions. Isn't that interesting?
Oh my.
Oh my. Yes, Sulu, thank you.
Well, thank you.
Yeah.
The viewing is getting better and better.
Yeah, Lamont is, it looks beautiful. Lamont is asking a question of, is the moon getting closer or leaving Earth's orbit? Well, it's getting about 2 centimeters farther a year away.
I don't get that. Wouldn't tidally locked mean it's stuck in that orbit forever?
It's stuck in that facing for now, but as it gets farther away from the Earth, it may eventually change. It depends if something comes by to perturb it or disturb it.
What if it gets far enough away it pulls itself from our gravity?
Well,
then what happens?
There is a prediction that it will possibly do that someday, but it won't do that until way after the sun has died, and actually engulfed the Earth and the moon in a deadly embrace and burnt us to a cinder. I mean, just saying. It won't happen. It can't.
Well, okay. Well, just for fun, what if it happened while we still had our sun? What would happen to Earth? And could it, depending on, okay, let's say it's moving further away from us and gets out of our gravity. No, Mars is smaller than Earth, so Mars couldn't catch it. Could maybe Jupiter catch it?
Well, keep in mind, the true scale of the solar system is such that it's going to be closest to the sun, and it's more than likely going to end up going more toward the sun overall.
So they've timed it to know.
No,
it would be closer. It would be closer to the sun than. No, on the opposite side of the Earth from the sun.
No, I'm just. But I'm thinking that because it's here, it's orbiting around the Earth, and its orbit's getting a little bigger every year. Okay, and there's consequences to that too. I mean, our day is 23 hours 56 minutes in length. Okay, and as the moon goes farther away, okay, then our day changes. The length of our day is going to change little by little by little. So now the thing is that understanding that, is something that, why would it, people don't understand why would that affect it? Well, it does because the moon has gravity. The gravity affects the Earth. The gravity causes tides on the Earth, and that causes that tidal bulge. This now, as the moon is moving away from us every year, this causes our day to increase slightly. All right, so it's going to be measured in milliseconds, okay, but it does cause the day to get measured to increase slightly.
Oh my God! I just seen a UFTC.
Unidentified flying
trash can.
Trash can.
Oh, T.
TC.
Where was it?
It went flying past the window.
Where?
Yeah, neighbor sighting.
The winds are
wind
ripping.
Oh.
UFTC. That's so funny.
Oh yeah.
I actually had a UFRC earlier. That was an unidentified flying recycling container, the big blue thing with a cover. Went sailing by at the speed of sound.
I'm kind of glad that you were smart enough this time to go out and actually anchor down the observatory, especially with these winds, because these are way worse than the winds last time.
Yeah, the winds that ripped that shutter off. Yeah,
that's crazy.
Yeah.
Let's see. Lamont says sometimes they say that our moon is abnormally too large as opposed to other moons for other planets. I agree.
Abnormally too large? Well, okay, it depends on the material and how the moon formed. If the other moons formed through an impact of a large object that struck them, that would make sense. But
I think he's saying just compared to its planet.
But look at the size of the planet. Look at the size of the planet and the material it had to work with and its nature. The Jovian moons don't have. If you impacted the Jupiter with a moon-sized world, it would heat up the atmosphere of Jupiter because Jupiter is just a gas giant. Right? But it wouldn't cause another moon to come out of it at all. It would absorb it.
Physics freak me out.
It's a different. It's different physics altogether. Yeah.
Well, I mean, just like you were talking earlier, it's like you would think that you got two bodies, that gravity. You figure they would gravitate toward one another, like say the moon and the Earth, not away. Yeah. It's just space. It's a meme.
Well, you have to study angular momentum to see why the moon is actually leaving the Earth, or disappearing, getting away from the Earth little by little. But again, it won't be doing so fully until way past the time when the sun has died. So it's literally 5 billion years plus from now.
Okay, obviously our sun's going to grow in the next billion years.
He's a little guy.
So let's say this planet gets hot.
Yep.
Starts warming up pretty good. How much time does it, like say we're able to go to Mars and we're able to make it livable, how much time does that buy us, do you think? Like, say this planet gets a little too warm, oceans dry up, but to go to Mars, it's still, it's almost becoming just right. How much time does that buy us before the sun grows even too big for Mars?
Well, it may not grow too big for Mars, but it'll grow too big for Earth, okay? The danger is that the red giant phase won't last as long as the stable phase of the sun. The sun's stable phase has lasted several billion years already, Now, it took basically half the sun's lifetime for, intelligent life to form on this rock here that we're on, all right? So in that amount of time, okay, again, in another 5 billion years, the sun's going to be in its end phase, and it's going to have gone into a red giant. So we have between now and 5 billion years from now, roughly, to do something. But if it was going into that phase now, or let's say we were on Mars.
Let's say we just make it off the planet, within, say, 100 years of it just totally, this planet being crap. And we finally get everybody to Mars. How much time does that buy us? Because if the sun, continues to go, even Mars is going to get hot.
Yeah, but it won't get uncomfortably hot. Mars is actually at the outer edge of the habitable zone right now. And as the red giant grows, okay, it depending on how that heat transfer happens toward Mars, I'm not sure that it's going to notice a huge increase or a moderate increase or a reduction. Mm-hmm. It depends, because the outer temperature of the red giant is going to be a lot lower than the outer temperature of the sun now. Mm-hmm. All right, because as it expands, it's going to cool.
So let me get this right. The sun is pretty much going to eat Mercury, pretty much.
Venus and the Earth.
So it's going to encompass that entire area.
Yeah.
So we should be aiming for a moon of Jupiter.
No. Mars. We could go to Mars, because Mars is actually substantially farther out.
Well, it's not really going to matter, because if we don't have a sun, it doesn't really matter where we are, does it?
Well, no, but the sun will be here for several million more years anyway. Beyond that.
We're just talking about
as a red giant.
Not.
As a red giant.
So you're telling me there's a chance?
Yeah, that's right. So you're not saying no. Yeah.
I had a question about the moon leaving our gravity again. I was just kind of thinking about it. Would it almost cause like a big tsunami that would like blanket most of the Earth in water? Is that not what would happen, kind of?
Well, where would that water come from? We only have...
No, just like I'm talking about, like, as if it was a magnet.
Well, it would just even out the tidal bulges, right?
Yeah, if the moon went away, then the tidal bulges, there would just be a medium tide everywhere, not a high tide and a low tide.
It wouldn't pull, like, the furthest ocean from it? Would it not try to pull it over to the other side of the planet? Do you know what I mean? Oh, I guess not.
No, I understand what you're saying, but the fact is that the way it works now is... Okay.
And then once it was out of the gravity, it would just snap back and then be still.
But it's not like it instantly goes away, though, to quote-unquote snap back. That's not how that would work. See, the way it works now, as I was saying, is that the moon pulls on this side, and because the Earth's rotating, that rotation, there's the tidal bulge that's created by the moon is kind of lagging a little bit, okay? And as the Earth rotates, the tidal bulge is kind of moved along ahead of where the moon is. And then on the other side, there's a tidal bulge that's induced at the opposite side as well. And they're kind of like at an odd angle to the moon. It's not directly in line with the moon, all right? It's sort of a little bit off. And that's caused by the fact that the Earth's rotating. And there's friction. The water has friction, and it's got some cohesiveness to the planet. And when that happens, see, that's why the Earth's rotational energy is being robbed a little bit, all right, by the moon's gravity. And so that, though, because the moon is going away from the Earth, right, over time, we're going to actually have the Earth slowing down a little bit, and the Earth is going to end up having those longer days I was mentioning. Mm-hmm. And then because of that, the moon is, as it drifts away, the moon is actually going to still induce tides, like it does all month long, but they'll be slightly less because the gravity is a little bit less. All right, and but if the moon disappeared entirely, we'd still have tides. All right, they wouldn't go away. We'd still have tides. Do you know why?
No, because we're still rotating.
We're still rotating, but that's that's not why we would still have tides. See, the moon is not the only thing responsible for tides on the planet.
The sun.
You're right. It's the sun.
Oh.
The sun also causes tides, but they're actually much reduced. So that's why, even as when we look at exoplanets, it's possible that life may still exist on planets that don't have a moon. Now, we had the benefit of very deep tides. That is to say, deep swings in the tide where we'd have tidal flats for a long period of time, and then we'd have water in them for a period of time. Then, tidal flats again in a monthly cycle. Well, that monthly cycle allowed for us to be able to learn how to live out of the water for a period of time. And that's why, because we started in the water, that's why when we started in the water, we ended up learning how to breathe for short periods of time. And that led to mutations that had life that would adapt to breathing air.
And that's where eggs came from.
And then eggs came from what?
Yeah. So you didn't have to, because the reptiles didn't have to constantly go back in the water to have babies. So then
That's right.
Evolution formed where you put water in the egg, put the baby in the egg, have it on land.
Mm-hmm.
Okay, there's a question for you, Keith. Tell us all how babies are born.
Oh,
well,
I think
first
you better be careful asking him.
Oh. Do you want the naughty version or the clean one?
Your stream, your channel.
Your penalties.
Yeah, really, I'm not the one getting banned.
Well, mommy and daddy have a fight. And then a stork comes with a baby.
Ay, ay, ay. What a crazy boy you are. A crazy boy. My.
I am trying to purchase the rights to Sagan's series, the Cosmos series, so I can upload them to this channel. And believe it or not, I think it's quite affordable.
Oh, yeah?
Yeah, I mean, you don't need like ownership rights or anything. You just need broadcast rights, and I think they're very affordable. I'm thinking about pulling the trigger on it.
Yeah.
Where I would have the Sagan library and be able to actually upload it here to the channel. Even though some of the science is outdated, but
is it a yearly fee? A yearly fee you got to pay?
I think it's a 5-year.
Okay.
Yeah. So, what it would be is we would be able to, if we wanted to, monetize it and make the money for 5 years off of it. And after 5 years, the monetization would revert back to publishing.
So the monetization, you'd get the 45 cents a year.
Yeah.
For the broadcast.
Exactly.
22 cents has to go to taxes, and
right.
By the time you're done, you owe the government more money than you actually made.
Right. I think that happened last year. Oh, what can you do? Life, death, and taxes.
Mm-hmm.
It's good to see Lamont back, though. Lamont hasn't been here in a while. It's good to see him back in the stream again.
Yeah, there's a few people that came back that haven't been here in a while.
Yeah.
There is a good question from a name I don't recognize, but maybe you guys would. JG? Yeah. I like that question. How come we can see both the moon and the sun at the same time sometimes? What do the people on the other side of the globe see if we can see both?
Ooh,
that's a great question.
I can answer that one.
JG. Yeah.
Well, let's have you answer it then.
Nothing.
That was going to be my guess too, but
it depends where you are, actually.
Well, where would you be?
Why do you say nothing?
Well, if you see the moon and the sun in the same sky, like say above you.
If I can see the sun and moon in Canada, what's Australia looking at? A black sky? And stars?
Go ahead, Mark. Drop some knowledge.
No. It's okay. I mean, think about it, though. Okay.
My answer's nothing. That's what you get out of me. Nothing.
Okay.
They will see a dark sky with stars.
My answer is, even if me and Canada could see both the sun and the moon, they would probably be at my east and west. So I would think the other side, whoever is on the opposite side of the globe to me would just see them in reverse. They'd see half the sun on the west, and I'd see it on the east, or something like that.
Well, I think you're both partially correct.
Way off.
No,
you're here.
And I'll tell you why. Okay, think about this. If you can see the sun and the moon at the same time, it means it's daytime. Okay, and that means that the moon, which spends half of its cycle in the daytime sky, all right, will not be in your nighttime sky. So at night, you will see no stars without a moon bothering you. Okay. Because the sun and the moon at the same time in the sky, as the sun sets, right? If the moon is to the right side in the northern hemisphere, if the moon is to the right side of the sun, then it means that the moon is heading toward new moon. It's near the end of its cycle.
Waning.
It's in waning. Yes, it's waning. It's
currently on path right now.
That's correct. After the full moon. And then
7.9% waning.
Mm-hmm. And so then, if the moon is on the left side, it means that it's waxing, it's getting larger, left side of the sun. But if it's in the daytime sky, it means that when the sun sets, the moon is behind it to some extent. And if the moon is close to the sun on the left side, then it means that the moon's going to set fairly soon after the sun sets.
But you will never see a full moon and the sun on the same side. Correct?
That is correct. The full moon is always on the opposite side of the sun. So
there you go.
That's right. At sunrise, okay, in the east, the full moon is setting in the west. And at sunset in the west, the full moon is rising in the east when it's a full moon. Because it's really on the opposite side of the sun. So you're literally looking all the way across the planet through space to see the Earth over there, the moon over there, and the sun over there, kind of a thing on the other side. So that's pretty cool.
So basically, when you see the sun and the moon in the daytime, the moon is still catching some sunlight, which is why you can see it.
Correct. And then, at night, it means that unless the moon is actually in, say, past first quarter, where it's looks like it's half a moon from here, which is really, it's always half a moon. No matter what phase it's in, it's always half lit. But when it's first quarter, as it appears from here, all right, then first quarter and before, then when the sun sets, the moon sets just a few hours later, all right. But if it's like gibbous and heading toward full, then the moon will be out for much of the night as well, all right. And that's again, after full moon, when the sun sets, you won't see the moon until later on in the evening. Okay, maybe around 10 o'clock at night, say, then the moon rises. So it's in that part of the cycle. But when it's to the right side of the sun in the daytime sky, then that means the moon is out during the early morning hours, and you see it in the sky, and then the sun is to the left. It means the sun is rising. It means the moon is heading toward the sun, because the moon is actually traveling from west toward east.
Well, speaking of full moons, last month on this channel we had a little poll going in the chat. That was pretty fun. We were going to name what it's called when we don't have a full moon in a month, which just so happened to happen this past January, because we had the blue moon in January and we have one here in March. So there was no full moon in February, and we took a poll in the chat, and we all agreed on calling it the elusive moon. Well,
That's right.
Sent a couple emails out, and it turns out there is an official name for a month that doesn't have a full moon.
Really?
Ours is better. Yeah. The official name for a month that doesn't have a full moon it's called the black moon.
Yeah,
I think ours is a lot better. And I think we're going to be calling it the elusive moon from now on.
Yeah.
Iridium Q36 explosive space modulator.
Yeah, right.
Moon.
Yeah, the official term is black moon. We call it the elusive moon. And we do have a blue moon this month as well. We'll get it full again, don't we, at the end of the month?
Mm-hmm.
Yeah, I think it's on the last day. So, yeah.
Yeah, it's thrown off because of March. Sorry, because of February's shortened month.
Yep.
So, we're looking at another question from Lamont. Is that what this is?
I see one from Tana, but...
Oh, I only see one from Lamont here.
Okay, what one do you have?
What happens if the moon is hit by an asteroid the same size that wiped out the dinosaurs?
Okay. No, I threw that one in.
There's no ozone to break it down or break it. Well, there's no atmosphere to slow down an asteroid. That's correct. In fact, the atmosphere on our Earth actually caused more destruction of the impact from the asteroid than it would be without an atmosphere, because the atmosphere actually heated up and it fostered forest fires around the globe, which ate up oxygen and also caused sediment to go high in the atmosphere into the stratosphere for years. I mean, killing the dinosaurs was only instantaneous for those dinosaurs near the Yucatan when this happened. Okay, the Chicxulub meteor was around 30 miles across or so, but the impact scar that it left was about 120, 130 miles across. So, you know, the bottom line is that if you actually did have an impactor that was 30 miles across hit the moon, we would see it from the Earth. If we could see it, we'd actually see a very, very bright light on the surface of the moon. And that bright light might last for, it depends how the impact hits. It could be a fraction of a second or it could be a couple seconds long. And then there would be a large debris cloud thrown up into the exosphere, and that's what you call it around the moon because there's no atmosphere. When it's thrown up into the exosphere around the moon. And then that debris will mostly end up falling back to the moon, where it leaves secondary craters. All right, but most of that impact energy is going to get translated into heat. That heat's going to get translated into light. We'll see the impact as a bright light that hits the moon at one point, and then when that stuff starts to filter back down, some of it's going to continue to hit the moon. Some of it, on the other hand, could end up getting launched so far into space that it's free of the moon and ends up coming into the Earth's atmosphere, causing some brilliant meteor showers and maybe some minor asteroid strikes. That could be on the scale of the Siberian asteroid or meteoroid.
You know what? That brings up a conversation I had the other night with somebody in chat. Because I take these moon streams and I compare them from year to year. So I take similar illumination, similar times, and you just overlap them. Okay. And a lady in chat was asking me why I do that. And I said to see if there's any differences. And then, of course, she asked what kind of differences. I said, well, just in case there's a new crater that popped up, I said that would be pretty significant. And she said, why would that be significant? And I said, well, okay. And I'll let everybody know in chat why this would be significant and why having years of data is actually good to actually put on top of one another and check out the surface to see if it changed. If, by chance, there's a new crater that it wasn't there before, that means that if we're seeing it, that was a pretty big meteor that impacted the moon that NASA didn't see.
Well, how do you know they
and
didn't
was
see it?
That close to Earth that they didn't detect it? Because you would hear about, if they knew the moon was going to get like something that big. I'm saying. I mean, obviously the moon is getting hit every day with meteors, as is the Earth. But I'm saying if we're seeing it through our telescope, a new crater, that is a pretty big meteor strike. That's why I do the overlapping. And it's yes, it's tedious. Yeah, I mean, it's just a year that I do it once a year. I go back and I go through, different moon phases and I take them, and then, of course I, transfer the opacity and layer it, almost like kind of like you do, Mark, with your images when you stack images.
Yeah.
To make them better. So these are just opactic images, But that's why I do it, just in case there happens to be a new crater there that wasn't there the year before, or 2 years before, or 3 years before. And yes, it's tedious, but I find it fascinating.
I think it's a great thing to do because, to be honest with you, it's like the people at planethunters.org. They can actually find planets in the exoplanets because they can actually use the Kepler data. Again, I've mentioned this before, some of which has never been seen before, and they're the first ones seeing it. And they go through and they actually try to find areas where the starlight has been diminished by a little planet crossing in front of it. And there are citizen scientists now that have found planets around other stars this way.
Yeah.
And using that data. So it's pretty cool, And I think what you did, what you do is a great idea. I mean, it's a wonderful thing to actually.
Well, obviously there's protocols in place, because if I do happen to see a new crater, the first thing I'm doing is jumping on Skype with you. And then we're going to go through all the LROs and every moon map we can find just to make sure that this wasn't there
we
before.
will.
Then we contact people, and then we make them let me name it.
This is Crater Icky's. Icky's 1.
No, it'd be like, and this is the new crater found in 2018. Its official name is Giggity. Giggity Crater.
Whoa, yeah, giggity goo.
Yeah.
Yeah, I don't know if you. Sorry, I don't know if you saw that in chat, Keith. JG just asked if you've recorded any new craters. So
no, I haven't.
That's
yet.
what.
No. But I do continue to check, and usually I'll grab 2 from each season when I do the overlapping, and I usually do them right around January or so, because the last couple of years the Terminator has been pretty much this year it struck right around the 1st. It was a full moon, so it was like the 1st or 2nd week in January I did it, where the Terminator was down, and I could overlap them. I usually take 2 from each season, so I'll do 2, from winter, and then I'll do 2 from spring, and 2 from summer, and 2 from fall, and just overlap them just to be sure, because obviously if there's going to be a new crater, it's not, that would tell me if it was there in spring or summer, but not there, say, in January or February. That'll tell me a time frame of when it actually happened. You know what I mean? And then I can go back through our streams and make sure it didn't happen while we were streaming.
Wow, that's cool.
Which would be cool. I'd love to see a meteor impact, a good one.
Well, usually, unfortunately, the meteor impacts for the new meteor craters that show up are usually found by the LRO teams,
right.
And they're usually small impacts that are well beyond the resolution of Paul's scopes, unfortunately. Exactly. So if you saw one that's big enough to be seen, then you'd be one of several million people that saw it, because there's a lot of people watching the moon. But doing those comparative studies is another way to find them, and I think that's pretty cool.
But can you imagine if there was a good size impact like happened just when we were just here watching one night on the stream?
Oh man, we'd stay glued on that one crater for the entire night until the moon set.
See a bright flash and all of a sudden a little poof.
Well, you would actually see a debris cloud. You actually see the debris. And then you'd say, "Wow, it's moving so slowly." It would be. It'd be elevated, in the exosphere for hours. It'd be hours up in the exosphere before it came back down. But that's like gently, the plume would be amazing. But you'd actually be watching it in real time.
It'd be raining plume dust.
That's right.
Very slowly.
I want to answer Tana's question.
Go for it.
She asked if other planets have. I think she means the aurora borealis, the northern lights or whatever. Mm-hmm. The answer to that is yes, as long as the planet has a magnetic field and an atmosphere, then the aurora borealis and aurora australis, the southern lights, will be visible. And all they are is just trapped particles that are trapped in the magnetic field, and then spiraling down at the poles where those magnetic field lines begin to concentrate. And we'd see them, around there. We see aurora borealis. We see the lights on Jupiter. We see them from Jupiter's magnetic field, and so that's pretty cool. But again, you have to have a magnetic field to be able to see them.
I tell you what, do another question, and then we'll do the shout outs for the people in the chat, and then we'll work on wrapping it up after that.
Okay.
You have any more?
Yeah, there's a couple more.
Yeah, go for it.
I'll just finish them up fast.
Yep.
Should I tell the chat it's the end of question time?
You can if you
like. Yeah, okay. Sure. JGS, another follow-up question is, when the moon is full, is it closer to the Earth or is it just an optical illusion? Well, that's a good question. When the moon is full, it's generally no closer to the Earth, but the moon's orbit is elliptical. It's not quite round. So we do have a time when the moon is like 13% brighter. And when that time corresponds with a full moon, you can actually notice it, right? But it is generally not noticeable. The ellipticity, the elliptical nature of the orbit, unless you're actually looking for it and measuring the brightness of the moon. But yeah, right. And Eric says, "How far could a human fall to the surface of the moon unharmed?" Well, basically, how far could you fall here? If you could fall 10 feet without breaking anything, then on the moon you could probably fall 60. Okay, it's 1/6 the gravity of the Earth. So if you can fall 10 feet here and roll out of it, then you could probably 6 times that on the moon and land unharmed. But you also have to roll out of it. The only problem is the lunar soil is like little pieces of glass. It's actually very sharp because there's no atmosphere. And so when you have molten material, when it cools, it'll cool very sharp like glass in these impacts. So
yeah, if you ever get a chance to go to a museum and see how messed up those spacesuits are, that's why.
Yeah. I was going to mention that one of the astronauts on the moonwalk, he couldn't do his last moonwalk out of the lunar module because his moon suit around the ankles was cut through right to the insulation. It was because he shuffled his feet as he walked, and that little tiny shuffling acted like glass sandpaper.
Would you compare it to fiberglass, or even tougher than that?
Oh, far tougher. I mean, we're talking about like silicon particles, like silicon particles that are sharp. Okay.
Right.
And fiberglass is somewhat more malleable. But no, these would be like rock, but sharp as glass. And that's something that no human really gets to interact with on a daily basis.
Right.
Now the lunar module in the interior was covered with it. In fact, it blocked some of the air ducts and stuff in there, and it literally blocked filters. It had to be removed, so they actually could get their air back and get their cooling. It was incredibly. It's a very hostile environment. Hostile to equipment, hostile to people. Very hostile to your lungs if you had to breathe it. I mean, it's like breathing powdered glass. It would literally kill you.
It's just another thing for humans to conquer, and I believe we will one day. We'll figure out a way to maneuver around the moon.
Yeah, just use stem cells to make new lungs, and you're all set.
Graphene.
Get a new set of lungs. Graphene.
I'm still in the graphene thing, man. I'm just totally.
No, that's fine. The graphene is the future. It's definitely the future.
I just dumped a bunch of money into graphene companies.
Good for you.
I know. I'm hoping it pays off. A couple different ones. There's a semiconductor company. There was a company actually doing mass production work that I did that you're able to get some buy into, per se. And then there's an offshoot of a college over in Switzerland that actually started a business out of it that I invested in it as well. So, I'm actually thinking about going to the graphene conference. I don't know if that's something you might be interested in, Mark, that they're having a show where they're actually putting on a bunch of, I have to get you the information. It's in the States. I know that.
When?
We'll probably, I think it's end of summer, if I remember correctly, it may be beginning of September.
Okay.
But they're going to show off the first paper thin foldable phone.
Wow.
And it's see-through. So you hold it up, it just looks like a piece of plexiglass. But it's as bright as a normal phone screen.
Yeah.
That's insane.
Yeah, it's just amazing stuff. Amazing stuff. And I mean, think about what that means for computer monitors down the line. Oh, man. Your computer monitor won't be sitting on your desk anymore. It'll be in your shirt pocket. You'll unfold it, put it on the table, or you'll just do virtual reality. Every time you'll tie in and you'll see things projected on a virtual image in front of you.
It's going to open the next wave of innovation, and not only because I'm invested in it, but I'm hoping it helps. Just being who I am, I hope it helps the space industry, which it's gonna, because you're talking about microprocessing and all that kind of stuff. Way later, It's just I could talk about graphene for hours, but well, with that said, you have any questions left, Mark?
Well, there's just two, and I can answer them real fast.
Go for it.
Charles Smar asked how many moon impacts have been seen by the naked eye. I know there's one that was caught by camera, and you saw it as a bright flash. I mean, it wasn't big; it was tiny. And when we went back to look, they actually found the impact crater.
Was that one caught by accident?
Yeah, they were just looking at the moon by chance. They certainly weren't planning on it,
Yeah.
Yeah.
I remember that.
And that one's available. You can actually watch the video online and see the little bright spot. So look up that. It's like lunar impact caught on camera. And Lamonte Dixon asks, is there anyone sponsoring a drilling site yet? No, there's no one sponsoring drilling on the moon at this point. Part of the problem is we have to get to the moon to drill. And we're not back to the moon yet. If this was 25 or 35 years from now, maybe 45 years, we'd be on the moon with a little bit more permanence. That's a really nice shot. I saw you messing with the contrast. Yeah. And that would actually end up being probably a place to drill. But what are you drilling for? You're drilling to get cores to try and see what's made, what the moon is made of. Because we'd like to know whether the composition of the moon, being so similar to the Earth, is just a red herring in terms of, there's a lot more stuff we don't know about deeper in the crust that settled out during the phase called differentiation as the moon cooled from molten heavier elements sifted to the center and so forth, or not. And like, for instance, if there was a vein of gold on the moon, we would never know because we can't get down into there. We haven't been able to get deep into the moon. If you look at the surface of the Earth, it's only rare that you have a vein of gold sticking out on the top. You might find loose gold nuggets that are washed by water, but the moon doesn't have that kind of weathering. So everything's locked up under the crust. See? And so we would have to have ways to drill into the moon and probably do tens of thousands of drill holes. So it'd have to be an automated process to actually see the mineralogy of the moon as through a drill study. We learned an awful lot about the Earth by drilling into it. Just imagine, we haven't done any of that to the moon. None of that to Mars. I mean,
I can't
wait.
Can
you imagine? I mean, yeah, we have so much to do.
But that's it. So much to learn yet. I mean, we barely scraped the surface of what the secrets of the moon holds. I mean, it's just I'm ready. I am ready.
Yep. I am so ready.
Let's get the space race going. However, I don't care if it's a race between Blue Origin and SpaceX or the United States and Japan. It doesn't matter. Send them all up there. Let them all compete.
It is going to be a private funded moon, in the future. It's actually going to be a privately funded moon base. Guarantee you. It's not going to be run by any country or any organization within a country other than a private company.
Let's just hope it's a company with good intentions and not bad.
Well, every company goes there. I mean, that's going to go there wants to go there to make a profit.
Well, of course.
The moon. I don't see anything wrong with exploiting the moon, because exploiting the moon means that the human race grows, and if the human race grows, we can get off the rock, get off this planet. Our sun will be dead in 5 billion years. We're going to have to find another home.
We're natural-born explorers, man. I mean, that's what we've
done
since the dawn of man.
We've
always moved forward and discovered, and we have this thirst for the unknown, and we're looking. We're at a time in human history where we're there, man. The interest is there, the drive is there, and the technology is starting to finally get there. So let's. I
agree.
With that said, we're gonna wrap up the stream for the night.
Okay, good, because I'm going to run too. I got to finish up my script for Sunday night's Sky Tour Radio.
But everybody listening and watching here on YouTube, be sure to check out Mark and Amanda on the Sky Tour Radio on KGRA Sunday nights at 9 o'clock. Maybe going for 2 hours soon. Right now the show's only an hour. If we are live on Sundays, we will carry it here. If we're streaming, we'll carry the show here on P&K.
Awesome. I love that you do that. Thanks.
The Sky Tour live stream will also be returning in March, I believe it is.
Just a couple weeks. Yeah, we'll be back.
Yep. So Mark will be back to doing his thing. In the meantime, I think we're going to do maybe 2 or 3 streams on this channel. We're just going to let Mark go ahead and stream on this channel.
Yeah, that's very nice of you. I'd love to use. I'll use your channel.
Yeah, to give people some exposure so they can go over and subscribe to him. Just amazing stuff, deep sky stuff. You're talking stars and nebula, and just be ready to learn. If you want to learn about space, that's the place to go. Once again, Mark and Amanda over there at SkyTour Livestream, Mark D'Antonio. I'm pretty sure Mark or Amanda can put the link to the YouTube channel up in the chat. And you do upload your Sunday a Sunday video too, don't you?
Yeah, we have the Amanda's she's a multi-talented person. She doesn't admit it, but she actually takes the radio show, but then takes imagery that I provide and that she finds and puts them into a video, so that for the concepts we're talking about in the radio show, you have something to look at that is relevant, and you can watch the radio show as a video on SkyTour Livestream channel, and I think she puts it on her own channel as well. And I think I put it up on my channel as well. So we we do that, and she also does the SkyTour News, which was a wonderful thought that she originated a couple months back, I guess. And it's the news for the day, for the broadcast day in history. It's wonderful, and she does a really nice job. Puts together the videos herself, does a great job putting them together. I love the fact she's just jumped in with both feet on this, and it really takes the SkyTour franchise and helps it push forward. It's wonderful.
Absolutely. And once again, that is the radio show is 9 p.m. on KGRA. You can listen live for free right there, KGRA Live.
Well, archives are free too, aren't they?
Yep, and you can listen to archive of the shows for free. They're all on the website as well. And we'll be back. We'll probably be back with a stream tomorrow night, being it's still the moon's still up early. And we might be on a little bit later. We might start at around 9:30, 10 o'clock, just so we can get it more towards zenith if it's clear, so we have nice still imagery. And if it turns out to be a really good viewing night, I'm pretty sure Paul will pull out the 11 or 12 inch scopes, just to see what we can do with them. So, yeah, that's it for us tonight. I'll let the music play for a little bit until Paul's ready to wrap, but we'll talk to you guys next time. Thanks for joining us. Thanks to the chatters. Thanks to the mods. And we'll be doing this again real soon. And Amy Title is possibly tomorrow night as well. I'm going to send her an email after the stream wraps, especially if it's going to be clear. I want to get her on here as well. So,
that's awesome. You've been threatening that for over a year now.
Our freaking schedules never line up, and when she's able to do it, we end up with clouds. So, and then I was thinking about doing a pre-record, and I was like, well, what fun is a pre-record? You know, if you want to ask her questions and stuff like that. But yes, the Apollo expert, she knows everything Apollo. Amy Title from Vintage Space here on YouTube, as well as a bunch of other programming, along with some of the Mark has done. So, yeah, hopefully we'll get her on. I'm going to send her an email right after this. And
she was on a couple of the shows I was on, wasn't she?
Yeah, she was on
There's Aliens on the Moon, I think.
Aliens on the Moon, and I believe she was on What on Earth as well.
Okay.
So, yeah, so that's going to do it for us tonight. We will be back tomorrow night, hopefully, if we have a clear sky, and we'll talk to you all tomorrow. So thanks, guys.
Thank you for having us on, Keith.
Yep, thanks, Amanda.
Fun. I think chat really enjoyed all the answers, and of course enjoyed each other's company too, and the wonderful sights you and Paul bring us. So, thank you very much.
Yep, thanks
another great stream,
everyone. We'll see you next
time. It was wonderful being here. See you
Have a great weekend, everybody.
See everybody. Thanks for listening and watching.
Yep, bye, guys.
Bye.